And is that my cue also?
Not yet.
All right.
All right. So good morning, everyone. It's really an honor to have you all today. We had a successful day one yesterday, a lot of sessions and tools, AI tools built in Tanzania. And today we are going to have even some better sessions than yesterday, I think. And we have various experts on board. They are with us in the room. So I'm going to let Dennis come on board so that you can introduce yourself and then introduce the speakers that we are going to have today. Karibu sana.
Awesome. Asante and Grace. Awesome. Thank you for this honor. It's really good to be here with this community. My name is Dennis Karugaba, and I serve as a resident tuning advisor assistant for the Digital for Tanzania project, which is government-to-government institute of cooperation between European countries and Tanzania. Specifically with this, we are working with 3 European countries led by Finland, but we also have Germany and Estonia. We closely work with the Ministry of Communication and Information Technology in the areas of cybersecurity, personal data protection, digital governance, and interoperability. And in that special way, we have a few guests today, a few experts from one of those EU member states, Finland. We have Mr. Kimmo Rousku. There you go. And then Tapani, Rinne. I'm going to let them introduce themselves and what they do in Finland and wow us with their presentation. Without further ado, I'll hand over the mic to them. Thank you. Go ahead, Kimmo. You're still muted.
So now you could hear me well?
Yes, we can.
Yes.
Yep.
Yes. And then I'd like to share, can you see our presentation? I tried to share it.
Yes.
So
yeah, we can see it.
The Tanzania deep learning IndabaX.
Yep.
Okay, cool. Well, then everything should be ready. So if now I changed the slide to digital for Tanzania, did it change? Yeah.
Yes.
Okay. Yes, because for some reason I can't see that as I thought. Well, now I can see. Yeah. So our agenda for the next 60 minutes. So as you already heard, Dennis introduced this EU project, and we are going to start with Tapani. He is going to give us presentations about AI and data privacy, part of cybersecurity as well. He will introduce himself, and after that, I'm going to show you a case example. Okay, before that, I'm going to explain a few things about how AI has already changed the world and actually how the digitalization has changed the world during the last 40 years and how the next 10 years could be becoming even more interesting than the whole 40 years which we have lived in this digitalized world. But after that, I'm going to show you an example of how I have 4 or actually 5 different AI services in use. How did I use that, or how I'm going to use that for trying to find out how you should develop AI cybersecurity together regarding the situation in Tanzania. So I collect a lot of information, and then I'm going to produce a report based on those, and then Notebook LM is going to produce us a podcast in English, but also maybe in Swahili, if I remember right, and it can make also a video. And then I'm going to send all of this material to you so you can find out how true is it. So this is a case example. Of course, it's a live demo, so anything could happen, but well, at least you get the idea how I already did try to find more information. But let's start with Tapani. So please, over to you, so you can share your presentation.
Thank you. Are you seeing my presentation? Oh, okay. I'm seeing it correctly, but I don't know why. Because Share window, you mean? Yes. Yes. Okay, good. Good. Hello, everybody. Good morning. So as Dennis said, we are here for the twinning project, Digital for Tanzania. And I'm going to talk about a little bit about data protection in AI age. We have this Vahti group in Finland, and we made supplementary questions for AI in DPIA, so data protection impact assessment. So when you start to use AI tools, you must do a DPIA, and because AI is a little bit different than every other personal data processing, you have to do a DPIA and use these supplementary questions, at least in EU. And I think this will work for Tanzania also, because Tanzania's law in data protection is quite similar to GDPR in Europe. So a little bit about me. My name is Tapani Rinne. I'm a senior specialist in digital agency in Finland. My current responsibilities are cybersecurity, especially risk management, data protection, and national situational awareness in cybersecurity and digital security in public sector. So this is a slide that I showed Monday in AI forum. Maybe somebody of you were present there, but when you start to use AI tools, you must remember, or we have to remember, that trust is everything in AI, in data protection. It's a fundamental for a human-centric and privacy-respecting digital future, and we must ensure that AI serves humanity's best interests. So we don't use AI just for the sake of AI. And core principles in AI, at least in data protection point of view, is trustworthy AI, and it must be lawful, ethical, and robust through its life cycle. And key elements is that we emphasize human agency and oversight and technical robustness, data governance, transparency, fairness, and accountability. Because in broader perspective, AI will influence our democracy our nations, our culture, the rule of law, and social justice. So we must embed this privacy by design principle so that we can integrate privacy and data protection into AI systems architecture from the start, from the beginning. We don't want to add privacy after we have started using AI tools, because then it's too late. So in the beginning, when we are considering AI tools, we have to conduct this DPIA, as I said, and use privacy enhancing technologies. And this is kind of because in EU we have AI Act. I think it's a year old or something like that in the EU, and the AI Act demands different kind of risk management when we start using AI. We have the traditional risk management, but we have also this new risk management where where we must study that is there a high risk when we start to use AI. So we must ask ourselves some questions like, does the legislation prohibit the restrict the processing of data, or is there confidential data or personal information? How we assess risks in AI use, and must the data be absolutely correct, because we don't want our AI tools to be data poisoned with wrongful data or something like that. So there are lots of questions that we have to ask that there's no need earlier to ask these questions in such an important way before AI age, but now we must do this and start to assess how we are using AI, why we are using AI. How's our competence in using AI? Maybe organizations have their own security principles. Does AI tool meet this principle, and so on? So we conducted a document in Finland so that we can add supplementary questions to DPIAs. And we did it in Excel form. I translated in English. It's not so pretty, but I can send it to you so you can use it or modify it in better use in Tanzania. It might not work as good as in Finland or EU, but I think it could help to produce your own tools for using AI and securing that data protection is embedded in AI tools from the start. So it guides controllers to identify AI-specific privacy risks. It supports responsible governance, lifecycle analysis, and transparency. It is aligned, as I said, with GDPR, but I think that also PDPA, so that's the Tanzanian privacy law. The supplement questions is grouped into 6 thematic sections. So there are basics of AI, human impact and responsibilities in AI principles, life cycle of AI service, development, governance and risk management, implementations of AI systems, and final reflections and go or no go questions. So I think the last question is something like, are we absolutely sure that we can use AI? If there's an answer no, then we cannot proceed with that particular AI tool. The key themes in the questions are necessity and proportionality. in using AI, data minimizations and legal basis, training data integrity and bias mitigation, so that the AI tool won't be biased for some particular group or something like that. Transparency and logging, human oversight and continuous evaluation, security, access control, and accountability. And in conclusions, these questions enhance DBIA process by ensuring AI systems are assessed for their specific ethical, legal, and societal implications. So that we can use selectively and fully based on our AI project's scope and context. And also because AI is global. Most of the AI tools are global. For example, these ChatGPT or LLM models and something like that. So we want to do global cooperation because AI can amplify both opportunities and threats. So we need this international cooperation so that every part in the world AI is ethical. We can align AI tools with universal human rights and ethical norms and tackle cross-border risks like surveillance, misuse, or algorithmic bias and misinformation. I did this translation with ChatGPT. I'm not sure if it's right, but I'm trying to pronounce it. Sorry for my Swahili. I think it says something like "Uaminifu kujengwa kwa hatua si kwa maneno tu." So trust is built step by step, not by words alone, and that means that we have to do these DBIAs and supplementary questions and take care that when we start using AI or at least when we are considering to use AI tools, we embed this privacy bit design. But I can show you the Excel. Where are the supplementary questions?
I was looking forward to this Excel.
Yeah. So can you see it?
Yep.
Yep. Good. So as I said, there is this six sections basic of AI and so on that I mentioned. And then we start to ask ourselves these questions like mapping questions. Is the organization acting as AI service provider, software developer, or as the implementer? And we can use this answer section of the Excel and comment and so on. Human impact of AI and principles of responsible AI. Is it proportionality of processing impacts to individual fundamental rights? And so on. I can send you this Excel so that we don't have to go all the questions, because I think there's something like 100 lines here. So there are lots of questions that we can ask ourselves, and in the end, we can see that can we start to use that AI tool, or is there some mitigation procedures that we have to take into account before we use the AI. But I can send this to you and you can see it if it works for you in Tanzania. So do you have any questions for me or comments? Or shall I hand it over to Kimmo?
There are no any questions. I think it would be really useful, Tapani, if you can share with me this Excel, and then I'll have maybe Anna Grace share with the members. I'm sure there's a young people would really like to make use of this. As you said, it's really important to make these measures for data protection right at the beginning and part of the design.
Yeah, absolutely, yes.
Yeah.
Yeah, so, and because no one has raised their hand to ask a question, I think Kimmo can proceed, and then we can take questions after he's done. Meanwhile, if there is any participant that would like to post a question in the chat box, you can do so as well. All right, thanks. Back to you, Dennis.
Yeah, so my job is super easy right now. Just to welcome Mr. Kimmo Rousku. Yeah, I'm sure you'll have interesting tools to share with us. Kimmo.
Yes, thank you, Dennis. And thank you, Tapani, for your presentation as well. So can you see my presentation over there? So it should be now, just a minute, my picture and my CV on screen, on present in PowerPoint. Can you see that?
Can see.
Yeah, okay, so yes. So first of all, I'd like to tell a little bit more about me because, well, I'm quite unique in a way how long I've been working with computers. So this is my 40th anniversary, kind of, because I've been using computers and speak about computers and ICT and cybersecurity, digital security, the past 40 years. So I gave my first presentations 15th February 1985. So I believe there are quite a many of you haven't even born that date, that year. So I've been really long using these digitalized services. Well, I've been involved in many things, like you can see over there. I wrote over 20 books in 1990s. My last book was published 2017 regarding cybersecurity. And I, as Tapani, we both work in Finnish Digital Agency, where we have Finnish Public Sector Digital Security Management Board, which we run. I as General Secretary and Tapani is Vice Secretary there. So this is our main job in Finland, to help the Finnish public sector organizations to produce safe and secure digital services, which every day they start using more AI there as well. So that's my main duty, but I also I'm quite active during my leisure time. I'm a vice chairman in Finnish Information Security Association. I hack myself personally. For example, I get a little bit of cold here in Tanzania because of this huge changes in air conditioning in different rooms and airplanes. So I get a little cold, which I could find out from my biohacker devices. I have different devices, how I can see how well I am doing. And for example, my last night was the best night for the, let's say, during the 10 days. So I'm getting better all the time because I use these devices. So if you are using LinkedIn, please connect there, because I share quite a lot of information in my LinkedIn profile about security, about AI, about digitalization. And during this trip, I have posted there a few posts regarding what I have seen and experienced here in Tanzania. And we are going to do that for the next few days as well. So just find my name, Kimmo Rousku. There's this IT and AI as well, because I'm going to show you AI Kimmo, my digital twin as well. So we both actually, AI Kimmo helps me to produce materials and gather new information quite a lot. So I'll ask him something. So AI Kimmo is actually, it's ChatGPT where I use its voice mode. Voice mode became available about a year and a half ago. And since that, I used it quite a lot. Almost, well, I could say that daily, because it's such an important tool for me. So how should I use it? So just a minute. Hello, camera. Let's put it so that it can me like here. Oh yeah. So he likes Tapani more. I can't help that. So let's do it. So I'll take the camera over there. And hopefully it can now zoom on better on me. So I can show you. Actually, yeah. This is my iPhone. Yeah. And here I have ChatGPT. And now I just put the voice mode on. Good morning, AI Kimmo. How are you doing this morning?
Good morning, Kimmo. I'm doing great. Thanks for asking. How about you? How's your morning going so far?
I just said that it was the best night for the last 10 nights, so I slept excellent.
That sounds awesome. It's always great to get a really restful night of sleep. Hopefully that means you're starting the day with a lot of energy and feeling ready to tackle whatever comes your way.
Yes. We are now presenting and talking about in Tanzania's AI community about AI services, and part of it a little bit of cybersecurity as well. Could you say three most important things regarding cybersecurity and AI in Swahili?
Sure. Here are three important things about cybersecurity and AI in Swahili. Usalama wa taarifa, ni muhimu kulinda taarifa za watumiaji dhidi ya ufikiaji usioruhusiwa. Uwazi wa AI, ni vyema kuhakikisha kwamba mifumo ya AI inafanya kazi kwa uwazi ili kuepuka ubaguzi na makosa. Ufuatiliaji wa usalama, ni muhimu kuwa na mifumo ya kudumu ya kufuatilia usalama ili kutambua vitisho mapema.
So, I hope that went well, because, well, as you can probably know, I don't as personally speak Swahili yet, but I'm learning every day more and more. So that's how I use, for example, AI Kimmo for this kind of innovations and help me to produce materials. And when I have something to ask, I use him or her to find these answers. But let's continue with my presentation. So over there, I'll find the right page where I am now over there. So before I go to my case example, I like to show you 40 years of digitalization. For first 10 years, well, the first IBM PC came onto market 1981, so it's been 44 years ago. But the first 10 years, well, that wasn't very innovative, because we didn't have proper internet. Actually, only in the 1990s we get the first World Wide Web services, and actually that was the start of the internet. Next 10 years, we get better mobile communication capabilities. I don't know how many of you have used, for example, Nokia mobile phones, first the feature phones and then maybe those Nokia mobile phones. Unfortunately, Nokia didn't realize that it's not the technology, it's the service what we are paying for. And then came Apple with iPhones, Android, with their services, and about 2015, Nokia, it didn't exist as we used to know, and it was for Finland. That wasn't a good thing at all. On the same time, we get all the time a little better and faster mobile connections. I still remember about 2007 and 2008 when there was rumors that we are going to get a really much faster 4G capabilities. And since that, 4G has been a major leap regarding faster connections to internet. Also in Finland, we started a huge, actually large scale of digitalized public sector services during that time period. So the last 10 years, we have more power, computing power, faster internet connections. We have moved from 4G to 5G. Here in Tanzania, we've been able to use those momentarily, not everywhere. Even in Finland, we can't use them everywhere. But also, I usually like to see these positive things and mention about those, but we also have this cyber criminality, which have gained a lot of attention during these last 5 years. For example, in Finland, we lost last year maybe $500 million to cyber criminals. $500 million. For example, in Germany, they lost $7 billion for cyber criminals. So that's a major threat. And part of that, my job is also, I'm trying to give advices to Finnish citizens how to use internet services more secure way. But the good news is that 2.5 years ago, we started to see first phase of these new large language model services, which have developed faster than any other technology during the 40 years I've been in this area. And the pace will get even faster. So it's impossible to try to estimate what kind of future we are going to have, for example, even 2030, 5 years time, because they are getting really, really fast, kind of an exponential growth, which will also bring us new devices, new services. We actually don't know yet what they are going to be, or are we going to need them? Probably we are going to need them. And after that, also, now we are talking about this, let's say, narrow artificial intelligence. So this is not that good as it could be. Now we are moving to artificial general intelligence, which can beat us humans quite easily. And maybe sometime in the future, we can have a kind of artificial super intelligence. And I'm a little bit scared of that. Even I use a lot of digital devices. I mean a lot. As I said, I am a biohacker. On my right arm, you can see 1, 2 devices. I have 2 smart rings. On my left, I have 1 more ring. I have Apple Watch. So I have now 6 different devices on my body. Nowhere else, only on my hands. But probably we are going to see new kind of devices, maybe some kind of implants, which we can put under our skin as well, to measure something which we can't measure out of our body. I could maybe use that kind of devices as well. But if you have read about those implants which connects to your brains, you know, over there, well, I don't want to do that if they became available. I don't want anybody outside to hack my brain, even it could be very interesting thing to try, but no, not for me. So, but if we are now today talking here about AI, it's everywhere. AI is a huge hype. The next one, it isn't AI, because during the next 10 years, the most important thing will be how we change the role of human so that we don't have to do some basic tasks first by ourselves, but instead we start using humanoid robots. Well, they could be humanoid, but I don't like, for example, if you remember now this Terminator movie by where Arnold Schwarzenegger is there. There's this robot. It looks really scary. So I don't look robots like that. I'd like them to be animal-based. For example, it could be, you know, a miniaturized giraffe or some other nice animal. I like llamas as well. Maybe I could have a llama-based humanoid robot moving at my home. But this will be a huge change. So we have to think the role of human again, because now AI, it's the brains for these humanoid robots. It will beat us humans because it will be kind of a next phase of artificial intelligence, which we put on those humanoid robots. So this will be a huge change globally, and we have to start preparing for it somehow. So a couple of notes. So please remember that always check the information you are going to publish, which have used AI before publishing, because there's hallucinations in pictures, text, images, videos, even in music. I create songs by AI, but well, usually there's no hallucination, or you can't find any hallucinations in music. But for example, for other kind of information, that could be possible. For example, I use this picture where there's a lot of giraffes in Serengeti. It's not possible to take that kind of a picture because there should be some other animals, and they are not looking quite normal giraffes. And the amount of giraffe is much too high. Probably there's ever a place where there are, well, 30, 40 giraffes in such a small area. So this is a hallucinated picture because I asked it to do it like this one. We humans are, of course, afraid of new technology, but it's not the first time. Since 1940s, so 580 years ago, human invented printing process. And after that, there's steam engine, electricity, internet, as I said, AI, and the robotics. So these are the 5 or 6 major innovations which we humans have created. And every time we are scared of what it's going to do us. Am I going to lose my job? What should I study? So AI, and as I said, the robotics. It's the next major innovation which we are going to use. So here is a picture which tries to explain it, why this is happening. So as you can see, it starts with number 1, 570 years ago. And now the capacity of, for example, electricity or ICT has developed billions of times, actually during the last 40 years. And it will gain this kind of exponential growth during the next 10 years. And I think I could say that during the next 10 years will happen about the same thing as the past 40 years, what we have or I have lived using these ICT services. So the next 10 years will be the same shift in technology as the last 40 years. That really scares me, even I'm so keen on this technology as well. There's another picture created by AI Kimmo. So how did I, for example, do this one? I use these AI services, deep search engines, capabilities to produce different kind of reports. And now next I'm going to show you this as a case example. So, sorry. So how should we develop AI and cybersecurity in Tanzania? So let's make a deep research analyzing using a few different LLM AI services. After that, I saw you, they produce more information, different AI services. Then I combine them by using Google's Notebook LM. If you should try some new AI service, if you haven't used Google Notebook LM, please try it. I found out today, actually yesterday, that there's a new version which can produce not only a podcast based on your information, what you are producing over there, but it can produce a video as well. It was really nice. That was a really cool demonstration. So how should we do that? Before that, I don't know, actually now when I see you in your class, how many of you have used in Windows personal computers these virtual desktops? Please raise your hand if you have used these virtual desktops. Now I can't see any more of you. Well, yeah, some of you. So instead of using multiple screens, I could use at my home, for example, three personal computer screens at the same time. But instead of that, I use mainly Windows virtual desktops. And there's the keys which you should use. And now it will be interesting to see what happens when I press here Windows and Tab. So can you, Tapani, show me what do you see here now on there? Yes, exactly. This is what it should like. Yeah, cool. So as you can see, there's in Finnish desktop 1, desktop 2, 3, and 4. So I have now 3 desktops, and now I am going to move from desktop 2, where is this presentation, to desktop 3. And the hotkeys are there as well. So you can create new desktops. So this is a new desktop. Why I'm going to use this one is because I have all my AI services ready in this desktop. So now I'm going to go back by using Windows, Control, and cursor left. So now I'm back my first, and then I'm going back to my AI desktop, and then I could have even one more by pressing Windows, Control, and D. And then it will create a new empty desktop. So this is the way I can use only one screen for multiple virtual desktops. So I go now back to my AI desktop. As you can see, I have already prepared so that all of my AI services are here. So this is, it doesn't show. Okay, so now I have to go back over this previous virtual desktop, which is this where I have my Zoom now. So let's go over there. So this is the Zoom, and now I have to try to share it again. So yeah, so now I'm there, and actually it might be so that I haven't used Zoom for these multiple desktops, so I'll do it so that I'll quit there. The other ones, yeah, now, and if I now go over there, let's see what happens. It doesn't show the right one, so yeah, I have to do it so that I quit all the others. So just a minute over there, and then I'll quit this one as well. Yes, and now we should probably see this better. So yeah, so now there's the presentation, and now I quit that as well. Yes, I don't usually use Zoom, let's say maybe once or twice a year. And that's the reason why I have some difficulties over here. So now, can you now see? So there's the presentation still going on. So I had to quit that one as well. So it's over there. And now that one, yeah, I close it there. So probably now there's my video. And now let's hope I can share this once again. So share, and I share my screen. And now it's on my video over there. So let's hope it's now sharing this one. Yeah. So now there's an OpenAI ChatGPT. I just wish I can get rid of this. Yeah, I have to put it a little smaller. Yeah, over there. And sorry for this hassle, but well, no, it's not that window. I have to share again this another way for that one, and now I will share it again. So let's hope I can find video, the right window. Yes, it's over there. Yes, now you can see the window where there are open multiple AI services on top of the window. So yeah, correct. Wow. So this is ChatGPT. And as you can see, I produced an example of Tanzania most known tourist attractions. So I just tested that it's working. So now I'm going to start this deep analysis using a prompt like this one. And I made this prompt so that I first did it by myself, and then I asked AI Kimmo to enrich it, and it made look like this one. So conduct an in-depth analysis of Tanzania's current landscape, etc. And now I'm copying it into a clipboard. So let's start it first here in this ChatGPT. I just send it over there, and it will probably ask me further questions. Yes. So before it can start, instead of a regular prompt, it asks me 4 questions at least. First, what is the target audience? For, let's put it government and academic. Then the next one, it asks, would you like any particular health, agriculture? Well, let's put it there, cyber security and education. Oops. Education. Third, do you want to report a focus on both development and deployment or just one of them? Let's put it both. And then the fourth one, spot security or broader. Let's put it broader. So think about it. If you should make a report like this one, how long would it take for you? First of all, try to find necessary pages information. Now I'm sending this one. Now it should start preparing this one. So aloitetaan tutkimus is in Finnish and means now it started this research. In the meantime, you can see that I have also Google Gemini here open. So I have Google Gemini 2.5 Professional open here. And I asked it to produce the same picture, and this is, I like this much better. So I paste here the same question, conduct an in-depth analysis, etc. And yes, it's a deep, yes, it's already, yes, deep research. Yes, it is. And then I just start and send it to it as well. And depending on the service I use, it could ask further questions before it starts. But now it's interesting to see how AI thinks about it. So now it's showing the process, what it's going to do. And this alone is very interesting to see, because now you can learn how it works. So usually we say that AI is a black box. In this case, it isn't that much, because now it's explaining what it is going to do. So now you can see it's reading and it's collecting information all the time. So that's going over there. But then I have Sora, which is OpenAI's picture or video program as well. So I asked it to do the same picture as the other ones. So this is looking a little strange, but these two are beautiful pictures. So this is only for picture and video modeling. For some reason, I don't know why, I have also XI's Grok available, but it can't connect for some reason. I don't know why. So we have to skip that. Then I have Microsoft CoPilot, and I put it here, this as well, and not as a quick answer. I choose here this there's think deeper, or yes, I'll use that one. So I will send this to CoPilot as well. Now, so now there's three sessions going. First is this OpenAI. Now it has 10 sources which it's reading. Then we have this Google going on. Oh, did it finish already? Looks like that. Or is it still doing? Oh, no, it's still doing over there. Ah, yes, actually, it has finished. This was quite fast. So the conclusion, all of this, is that Tanzania has the opportunity to chart its own course in the AI era, etc. And now I can show these sources it has. So there are the sources it used on this study. So you can confirm that there could be, of course, hallucination here as well. Based on these sources, it seems to be quite reliable. So what I'm going to do next is that I'll copy these here to the clipboard. So over here, and the last service I have available here is my Google Notebook LM. As you can see, I've been using it, for example, a little bit similar case a few days ago. It was a little different, but anyway, I have already used this. I start a new notebook. And what should I do next? This needs information. This is a kind of a rack kind of an approach. So I can add their sources, which I use only for this study. So I can either have files, or I can use, in this case, I can use my copied text, which is on clipboard. So I said copy text, I put it there, and then I add it. So now it starts this notebook, and now it's reading what I copied over there, and it should soon produce first information. Yes. Yeah, and then let's hope that we have another program there ready. So let's go to Microsoft. Yes, it has comprehensive analysis there as well. Yep, it has. And then we copy this as well. And we put that on there. So this is a new source I like to put over there. Also over there. And sources, I'll add, and I'll copy text there as well. And let's hope that Google has had time to finish as well. Add that over there, and the Google is there. Yes, actually that we already did. And then, as you can see, OpenAI is still working on there. So because I have only a few minutes time, I'll go back to there because we don't need that OpenAI's answer because we have enough information here. So after you have all the information gathered there, so now there's two sources. Then what I should do next is that I have here different kind of a studio where I can have audio. I click over there. It starts collecting, making a podcast on this general video overview. Now it starts creating a video based on this information. Then there's a map. And now it's going to produce a visual map about this presentation. And then there are different reports. So these are, for example, UKK is frequently asked questions. I put it that. And there's a timeline. If there are any years or something else mentioned, it will produce a timeline. And then there's a study guide. This is the second most important. And there's this information package. So I can have now 6 different views to this material, which I collected here on this notebook LM. Now it's producing these. And for example, study guide will look like this one. Study guide means that there are questions and answers. So as a study guide, you can use this for this kind of information, and also there's a vocabulary as well. So you can see that there's a glossary of key terms, or if there are any persons mentioned, it will collect all the names there as well. So this was one example. Let's have a look what else could we have over there. So the sources are only these 2. You can put there any page link as well. You can download PDF or copy paste like I did here. Also, you can ask questions based on this information you have here. But the studio, here you can gather a different kind of information. And let's have a look if it has, there's the roadmap. Let's have a look over there. Yes, there's this roadmap. So this is the combined roadmap based on all the information it has there. So probably, yeah, there's this timeline, potential benefits for Tanzanian society, etc. So yes, it could do that. And then let's have a look if it can. Yes, it has timeline and key players. As you can see, this starts from 2022. There was a digital Tanzania vision, and then there are roadmap for, well, in quite detail, cast of characters, organizations, possible persons over there. Yes, you can find them there as well. And probably it will take some time to produce this podcast and a video, but I will send you a link so that you can listen to this podcast and you can see this video as well. So this is the new kind of method how you can collect in a very short time, a lot of information using these deep search engines, and then use deep LM to combine different kind of views to your data. So I really highly recommend it. You can use this free of charge, this Notebook LM. I use a professional version. It's probably about $15 a month. Also, this AI Kimmo, I use OpenAI ChatGPT, the version that costs me $20 a month. So I use those two versions, commercial versions, but they are, for me, worth the money. So I'm a little, well, 1 minute over time. I don't know if we have time for a question, or are there already questions on chat? I'll do my presentation here and demonstration. Thank you.
Thank you. Thanks for the opportunity to come to talk with you guys. No questions, I think.
Yeah, I'm not seeing any questions.
Oh, somebody raised their
okay.
hand.
This is Juma. Go ahead, please.
Yeah, thank you, Kimmo, for your good presentation. And my question is focused on the future of innovation and the AI. Particularly with the innovations from the 40 years back. How do you thought on the next innovations, particularly in the AI, the future of AI and the robotics? Is there any revolutions, or what the people use those next evolution for technologies, particularly in the production or in human activities like education, health, and everywhere?
I couldn't completely hear your question, but based on what I heard, the evolution of AI, it will create us new problems, but on the other hand, it will also solve our problems. For example, usually when we talk about AI and data services and how much they, for example, consume electricity, huge amounts. Estimation is that from 4 to 8% of current electricity is needed for these AI data centers globally. Of course, that's not a good thing, but on the other hand, hopefully these new AI services, when combined with, for example, quantum computing, they can solve and produce as new economical ways to produce these services. So when we invest on new technology, I hope, think, believe, trust that it will solve these problems it self creates for this new technology as well. So of course, I'm really optimistic on this technology. So I always try to find the good things regarding this development. I don't know if it exactly answered to your questions, but this is my point of view. But also Udom has raised his hand. Please go on. Did you hear Udom?
So that's the University of Dodoma.
Hello. Hello. Yes, thank you so much. This is Dr. Jabera Matogoro. I appreciate for the wonderful presentation, and just wanted to check how do you see the role of university or academia, especially pushing and supporting the local AI ecosystem? Because I know Europe has done some wonderful steps, and especially on the data privacy, security, and I thought, how do you see the role of universities or academia? As you might be aware that the Tanzania have used the quadruple headache model, the one I mentioned yesterday, and we are thinking on how we can enhance our participation to the current AI ecosystem. That was the first question. But the second is we have seen global AI tools like what you have mentioned, Notebook, but also ChatGPT from OpenAI and others. So you say or the local AI innovators are doing the global tools like ChatGPT, or doing to make our own ChatGPT in the Tanzania context? Thank you so much.
I'll start with your last question. I use these global services because I need a general kind of information. But the good news is that there are so many open source based language models that it's excellent to start using and developing using them. So please study them. Teach them to your students, help them to create new local services. 5 years ago, or let's say 3 years ago only, I was afraid of that there will be only few major AI services available, but not anymore, because there's so much available open source code, open source servers, programs to use. And that's the way you should start using it. They are free of charge. If they are openly available, you can have also their source code, so they should be secure, or you can make an audit to those source code. So that's the way how you can develop your own local, very highly classified kind of services. And the role of the academia in Finland, we have a close cooperation with Finnish universities. For example, Aalto University is probably the most well-known Finnish university. There are, even in our Vahti group, we have members from our universities and also other academias as well, for developing not only for cybersecurity, but also AI services as well. And we need actually every partners we can have, which have some kind of a role to develop AI or cybersecurity. Because if we concentrate just only on one point of view, it's not broad enough. That's the reason why we should have all kind of different partners thinking about together. For example, like we have been now in Tanzania only a few days here giving presentations. It's been so nice to find out that you have, for example, now I can see this smart glass view over there. You have different kind of persons, organizations, partners there. So cooperation it's vital, because otherwise we miss something that some else organization might have invented, because if we don't do the cooperation, it's not a good thing. The same is with cybersecurity, AI, everything we should cooperate more, because the problems are alike all over the world. Wherever I go, we discuss like these things. I find out that, well, we have the same problems. So probably we should solve them more together, as we hopefully in the future are more.
Yeah, and I also think that universities has a key player role in raising public awareness about AI, because universities can bring the AI tools to people, and so that people aren't afraid to use AI. And of course, universities can use AI tools in research, so they can do the research more fast, more thorough, and get some new research results because of AI tools. So I think also that universities are key players in AI.
And please start using AI at your home. Don't think about it only for your studies or for your work or whatever, but start using every day. And don't do it by yourself. My main problem is still that even I use AI daily. I many times start doing by myself. Instead of that, I first ask AI, Kimmo, what should we do together? That's my main message to you. Start using AI in everyday services. Whatever you do, ask from AI first, how should we together solve this problem?
Really exciting. If you want any help with that.
Thank you so much. Means that you can consult it anyone. Thank you very much.
Sounds like
And I also appreciate you don't have you can also contribute.
Unfortunately, we can't hear.
AI uptake and AI adoption.
Oh, I didn't get that. The voice to us didn't work.
Yeah, we couldn't hear that. There was some noise over there. Can you write it on a chat?
Yeah, no, I was just appreciating for your wonderful feedback, and I also highlighted that we should take AI as a conversation tool, which we can just consult anytime we want to use it. Thank you so much.
Yes.
Okay,
Thank you.
I think we have to finish our presentation, but it was a pleasure to be here, and I will send all these materials I have gathered. For example, I think the Google has finished there as well. Sorry, not Google, but yeah. Took 8 minutes to go through 23 sources, 61 searches, and now also we have this report over there. So I will put all these together and I will send them to Anna Grace for further distribution to your community as well.
Thank you, everybody.
All right. Thank you very much. Dennis, just wait. Thank you very much, Kimmo and Tapani, for the amazing presentations. I think we almost even forgot that time has passed 9:30.
Yeah.
But thank you very much. I was amazed to know that I could even hack myself. So Dennis, just to sum up, maybe just a word from you, and then we can push on to the next session.
Yeah, nothing else. Thanks the AI community. I've seen all the classes that have gathered together, Udom, Zumbe, and the rest. I appreciate this opportunity, and thanks for Kim and Tapani for their presentation. I will share with you the DPIA questions Excel sheet so you can share with the community. I think that may come really handy when it comes to designing AI systems. Otherwise, thank you, and I wish you a great day.
Thank you.
Bye-bye.
Thank you very much. Thank you. And you're welcome to join in. You're welcome to join in any of the other sessions as well, just to follow up, because it's going to be the same link for the rest of the sessions.
Oh, okay. Good to know. Thank you.
Thanks.
All right. Karibuni sana. All right. So to all participants, thank you very much for the nice participation. And right now we are going to quickly move to the next session, and we're going to have our very own experts. I'm sure most or some of you know some of these faces. We have Dr. Dina Machuve, who is going to be with us for a session on Introduction to Multimodal AI. And then later on, after break, we're going to have Fredy, Mgimba, as well as Innocent Charles for the AI Tools Challenge. So karibu sana, Dr. Dina. You're in the room, right?
Yes, I'm here. I hope you can hear me.
All right. Yes, we can hear you. So you can just start by introducing yourself and then move on with your presentation. Karibu sana.
Okay. Yeah. Thank you so much for inviting me to the IndabaX 2025. I'm Dina, based in Arusha, and currently I work on the startup Dev Data Analytics, which I co-founded. We are working towards developing AI tools that are applicable in low resource settings. We understand that we have revolutions happening with AI, but how do we make use of these resources in low resource settings where internet is limited, and also we don't have very sophisticated device. That is what DevData is striving to achieve. So today we'll walk through with you on multimodal artificial intelligence, or multimodal machine learning. We will walk through together on how can we use resources to develop multimodal models to address certain challenges that we have. And we understand that multimodal machine learning really refers to those models that are capable of processing information from different modalities. And by modalities, these could be images, videos, text, audio, how do you process this information from different modalities using a machine learning model? So that is what multimodal machine learning is about. And let me see if I can share with you the walkthrough that we'll go through together on this use case that uses multimodal machine learning to address the different challenges. Yeah, okay. Yeah, I hope you're able to see my screen here. It's Collab Notebook. Okay, so we have here a case study, just a real example of what multimodal means. You have a question that you are prompted, what is your favorite dish? And we have different users responding differently to this question. When you are asked what your favorite dish is, you can respond by text, explaining, describing what your favorite dish is. My favorite dish is ugali and beans. Okay, so you can describe your favorite dish using text. Okay, you write on a chart saying my favorite dish is ugali and beans. Another person can respond to the same question by giving a picture of that dish. So can display a picture of ugali and a plate of ugali and beans, and that really describes that it is the person's favorite dish. So that is really another modality of responding to the same question, that you're using image. And another person can respond to their favorite dish based on the nutritional content of that meal. Like here, you understand that your favorite dish is ugali and beans, but it has different nutritional content in terms of carbohydrates, which are there on the ugali, and then we have proteins and certain minerals on the beans. So we have different modalities of responding to these different questions that were prompted, and that is what multimodal is about. How do we model now all these responses and be able to give a user a definite answer to that question? So that is what multimodal is about. We have different modalities: text, images, audio, and we have to model that and be able to respond to a user accordingly. So the first step of developing a multimodal system based on those different responses from users, really it involves what we call developing embeddings. So we have different embedding models. Well, for a user, they see the different modalities, but when it comes now to machine learning, we have to encode that and have a common space, which we call the embeddings, in order to be able to respond to the user accordingly. So if you have the prompt, the modality being used as text, then you'll have to use a text encoder to develop embeddings, which are really vector-based embeddings. So they are all converted onto vectors based on basis of the different encoders, and you are able to get the different vectors, and these are the ones which are used in the decision making and be able to give the user a response. So if your modality was image, it will go through an image encoder, and you are able to get a vector space for that encoded image. And also you'll have this one which gives nutritional facts. You can have a specialized encoder, and you are able to get these embedding models. And this is where multimodal machine learning comes in, where the different kinds of encoders are used to produce the different vector embeddings. And it's quite important, really. We have this multimodal recommendation system, which will walk through together on how you can develop. We'll go through a use case of developing a multimodal recommendation system. It really allows us to deal with different kinds of modalities. And because we have people with different perceptions. When you're talking about your favorite dish, someone looks onto the picture, another one, they read on the nutritional facts, and another one can deal with the description of the dish in terms of text. So our use case here is a multimodal recommendation system. We'll go through together this workflow, but I will also share. I will share this notebook with Anna Grace later to really make it user friendly. I want to really encourage members of the community to develop a multimodal recommendation system for different use cases that you have at your workplace, or even the community. You can have a different case and a different problem you want to work on, and you can go through this. You can use this workflow to develop a simple recommender system that is multimodal, deals with different modalities. And so we're going to use a flowers data set that is on Hugging Face. So on this workflow, the first step is actually you have to get the data set. And we'll use this data set, which is a data set of flowers on Hugging Face. So you try to recommend different kinds of flowers for different use cases. And then we're going to save the images locally. And after you have the images now, you have the images. Remember, we have to create the embeddings, okay? So we go through an image encoder in order to get these vector embeddings. That is the third step here. We have the images locally in your directory, and now you develop the embeddings, which will be stored onto a vector database. And then now you try to prompt on this multimodal system. And when you do the prompting, is actually you're working onto the vector database. Yeah, and then you are able to test. So this is really the workflow that I'm going to work with. So this data set is here on Hugging Face. And here, if you want to know more about this data set, it shows very well how you can use it. From data sets, you have to import it, and it really explains what the data set is about. And it has about 8,000 images, okay? So the first step, as usual, is about importing the different libraries that we're going to use, and this one is also for importing the data set. And we're loading this data set onto the cache, or I'm running the notebook on Colab, okay? And we'll check on how many rows are we able to obtain from this data set that we are actually downloading from Hugging Face, okay? So it is also here, it downloads that data set from Hugging Face, the data set of flowers, and you see here there are about 8,189 flowers. So it's quite a good number of flower images, okay? And we can try to view. Here you can view any. I chose number 78 out of the 8,000, but you can select any. You can put any number of flowers, maybe 719, and display it. Let's see the different kind of flowers. But this is a general use case, but the main motivation is really to motivate the community to address challenges that use the custom data set, or in your workplace, work on a machine learning problem that uses multimodality. So this is one, a sample flower. So we are able to download a data set of 8,189 images, and here we've been able to display one flower. What I put here is a function, actually, is actually this case, but I put it as a function to be able to accept any image that can come. We'll use this later on. Now that we have 8,189 images, but since it's a small case, we're going to use 500 of them that we're going to actually use in the multimodal in the multimodal case of producing the vector embeddings. Okay, so I'm going to save these locally, meaning on my Google Drive. So I will have a folder called flower dataset, and I'm going to save these flowers there locally. Okay. So here I'm defining the folder that is going to save the flowers, and here this function here saves the images. Okay. And I want 500 out of the 8,000 because these are the ones that I'll use to produce the vector embeddings, okay? And I want to make it quite interactive, that as it saves the image, it should print which image number. And those flowers have different names, but I renamed them to be flower 1, 2, 3, up to 500. And then when it finishes saving them, it should give me a prompt that it has saved these images. So this is actually a function to save the 500 images. And this here, I'm calling this function to save those images locally. Out of the 8,000 images, we're going to work with 500 that we're going to produce the vector embeddings. So as it continues here, we are on stage number 2 of of saving these images locally, and I'm saving them on the Google Drive. So there are 500. I'm just choosing that because of the compute, choosing 500 images that we're going to use to produce the vector embeddings. Yeah, so we're dealing with the images, and for this case, we're going to work with 2 modalities, text and images. But again, we understand multimodal is wide. You can deal with video, you can deal with audio, text, and images. Excuse me. Yeah. Okay, so it's we are saving out of the 8,000 images that of the flower images. We're going to continue working with 500 of them that we're going to use in converting them onto vector embeddings, which we're going to use in the multimodal. Yeah. Okay. Yeah, it's almost finishing here. Yeah. So we have saved the first 500 images out of the 8,000 locally. Okay. And our third stage is actually now to save image embeddings to vector database. So we're going to convert these 500 images go through an image encoder to obtain a vector database. So every image is going to have a corresponding vector, okay? And that's what we call the embeddings, which are saved onto a vector database. For that, we're going to use what we call ChromaDB. Essentially, ChromaDB is an open source. It's an open source. It's an open source. It's an open source. It is open source vector embedding database, and it's very fast. Sorry, and it deals with multimodality. And so this is the library that we're going to use to convert those images to obtain image embeddings from the 500 images. So it's ChromaDB, it's open source, very fast, and it supports multimodality. Okay, and also we're going to use the open clip, which is also works with ChromaDB in order to produce the embeddings. I already they take quite a lot of time, so I had already installed them. So what we're going to do here is actually now import ChromaDB, which is the open source database that converts images to embeddings, and we're going to be able to create an object, which is what we call as we can call this our flower database, which is now the vector database. It's also going to be locally, and where it means here we are working on developing an object, which is a database, okay, that will store those embeddings, okay? So that is how we are initiating it here, okay? And then we are loading images now that are converted to, so you have to initiate the image loader. And now here we're using open clip embedding, which is within ChromaDB to do the multimodal embedding function, create those databases. So we also need to initiate that. And then we create our collection, like our table. Okay, we have the database called flower1.db, but within the database, we need to have a table that will have those the database that has we need to have the database that will store those images. Okay, so that is what we call the flower collection. So here, open clip is the embedding function is being downloaded from OpenAI. Okay, it's open source. And now here, what we are going to do now, we are going to create a collection called the flower collection. That is a table that will store all the vectors, all the vector embeddings. okay? And now we store them with IDs, and you're going to have corresponding URIs for each image. So for a file, we have flower 1, flower 2, up to flower 500, okay? So, and the file name have extension of PNG, okay? And we have to iterate over the dataset folder, okay? And then we are going to add them to flower collection, okay? So that's how the vector embeddings are created, and this is how they're being created now from the libraries we have initiated, and they're being added. The vector embeddings are being added to flower collection. Means you get or you create the collection, and then you have the embedding function, and you load the data loader. You are loading each image onto that. So here, this is where now the vector embeddings are being created for the 500 flowers. Okay, so this is where the vector database is being developed for each image being encoded using the image encoder, okay, the ChromaDB and OpenClip, and they're stored onto this vector database, onto our table of flower collection, okay? So that is what is happening here, that we're using Chroma database, which is open source, very fast, and then we're using the multimodal embedding function within ChromaDB, which is the OpenClip embedding, and we are converting now the images onto vector and store them onto a database, okay, a vector database. So now it's now an embedding. It's no longer an image, but it's now a vector embedding. That is what is happening at this step, okay?
Sorry.
So, yes.
While it is loading, I want to ask that what the dimensions of that embedding that's being produced by ChromaDB? Is it by what dimensions? I want to know.
That's a very good question. It's multimodal, it's image, and it's a vector, okay? And we understand that an image is a three-dimensional because it's colored, okay? And when you convert it to a vector, it is flattened, okay? So it is quite a high-dimensional vector. And it depends on it varies from one image to another. But when you consider just what happens, for example, in convolutional neural networks, okay? Let's take an example of digits. That would be a simple one. Which has 28 by 28 pixels, one digit, say 1 or 2. And if it's a gray scale, it will be one-dimensional. If it's so if it's one-dimensional, that will be 28 times 28. That will be 784 pixels. Okay, and when you flatten it, it means it will be a matrix of 784 columns. So if you times 3, because it's three-dimensional, depending on the input image, so you can just think of how big it is. Yeah, depending on the different inputs. If it's a three-dimensional image, it could come with say 224 by 224 times 3-dimensional, because it's colored. Okay, so when you flatten it to become a vector, it's 224 times 224 times 3. So that's the length of that particular vector. So it's huge, and that's why all these are covered on these different functions. Times the number of images, we have 500, but again, it's a vector database. They are arranged in rows. I didn't include a viewer of the database. I will do my best to curate that on the notebook that I will send, I will share, at least to show you how the vector database looks like and what dimensions there are. But that's the thinking that I have, that an image that is colored is 3-dimensional, and you flatten it in order to make it to a vector. So if it's 224 by 224 times 3, so it's quite lengthy, the vector length for an image. So I hope I've answered it a bit, but I promise that on the notebook that I will share, I will include that so that we have a feeling of how that vector database, the entries of the vector database are like.
Okay, big fine, yeah.
Okay, thank you. So here we look onto the flower collection database, which is on the ChromaDB. How many entries, how many vectors are there? Okay, and it's 500. So there are 500 vectors, okay, and each one has that length of the flattened image dimension, which I will definitely include on the next one, or at least for you to get a feeling of how it looks like. And then now we have the vectors on the vector database, okay? We need to be able to query that database, okay? And if we come here, if we come here initially when when I shared with you on the different modalities, and they're all in vector now, okay? So they are now all on the vector database. They're all, if it was text, it is now a vector. If it is image, is now also a vector embedding, okay, through the different kinds of encoders. So now that they are all on the same space, the vector space, that means you can put in a text query that will also be in vector format, and you can get a response that can come onto image format. So they are now on the same space. That's where we can go onto the fourth stage now. How do we query all the now that they are all stored onto the vector space? That's where now the queries can come, the promptings can come in. Okay, and so we look onto these. We develop a query which is actually in text format, okay, and we are able to receive the results. Now, on the database, we have what we call the distance, okay. Look onto the what is the distance. The closer they are, the more similarity they are. So the distance is actually a similarity check, okay, and you are able to get the results, okay. So you can query using text, okay, and you're able to show the corresponding image for that particular query, okay. So up to this stage, now a query can be in text, okay. Display for me purple petals, okay. You can change different. You can create. This is just a simple one, and give me the results from the query. Give me 5 results for each question that I ask, okay? You query this database for, you want to see purple petals, and print for me the results, okay? On the results, show the file name and the path of the image and the distance. The distance shows us is a similarity check, okay? So let's taste our system, okay? So we are querying for purple petals, okay? And we want to be shown the first 5 results, okay? Results should come from the flower collection. This is our vector database, okay? And display for us the results, and also the URI, the path of the file, okay? And also the distance. So we are looking on to, we want, now all these are retrieved from the vector database. We're looking on to 5 we're looking onto the purple petals, okay? The ID is 15, the distance is 1.41, it's a similarity check, okay? And this is the flower 112, okay? The PNG, okay? So this is a bit purple, not very close. And the second one you see is quite a purple flower, and you have the details. And here it has a bit of purple, that's a third one. And then a fourth one here comes, is also purple, okay? And we want 5 results, okay? And this one is also a purple. And when you look onto the distance, it's quite similar. For this one, it's 1.423, 1.41, they're quite close, so they're quite similar. The different, for the different images, the distance becomes as close as they are, the more similar they are, okay? So it doesn't differ much, okay? 1.41, okay? So we are able to query the, the vector database, okay? We can change this, say, you can say maybe pink flowers, okay? Pink flowers, okay? Let's see what it brings us, okay? Okay, yeah, we want our query, we are querying the database, we are querying the vector database that we developed from the data set that we have, okay? So this we are querying using text, okay? Pink flowers, and our output is images, okay? You have the different images which are coming up, okay? Now, up to this point, we are querying the database, okay, that we developed using the data set. So we're getting the different kinds of flowers, okay? Now, up to this point, we can say we have a multimodal retrieval system that we are able to retrieve from the database that we created, okay? So this is a retrieval. That is a multimodal. We are able to query with text, and we develop this database, okay? And we are able to query we are able to run the query from on it, okay? So it's a multimodal retrieval system, okay? And now the next stage is, so this is multimodal retrieval system that we are able to retrieve from the, we're able to, sorry, this is the issue of RAM, sorry for that message, okay? And we are able to retrieve from the vector database that we developed, okay? And now to make it robust, okay? Because this is only the data set that we had. We had started with 8,000 images, and we were able to develop a vector database that has 500 images, and we're able to run query on it and be able to retrieve results, multimodal. We're putting in text and we're able to retrieve images. But now to make it robust, okay, we now need to submit, we set up a RAG flow, and I've seen on the timetable, we'll have a colleague speaking more about the retrieval-augmented generation, okay? So to make it more robust, we incorporate it with a large language model, okay? So we have our vector database, we incorporate it with a large language model in order to make it more robust, to receive more queries and get more useful responses, okay? So when you have a user submitting a question that is wider, okay, so it searches over a large language model and incorporate it with the multimodal database that we have, okay, the retrieval system that we have, and we make it more robust with a prompt, okay? But again, now, when we work with incorporating with the large language model, because it's multimodal, we have to select one that supports vision, okay? Because we deal with images, okay? And and also we have a standard format of formulating the prompts, okay, in order to be able to get the right answer. So we use this framework of LangChain, okay, which is a framework that links now the multimodal vector embedding database that we have with the large language model. It's a framework that enables us to be able to link with large language models. And images, they have to be converted to what we call base 64 in order for them to be understood by these vision model. And that's why we have here what we call the base 64. And again, I will share with you, I had issues with the GPT-4 or he has vision capabilities, okay? So that's the reason of choosing GPT-4. But I had issues of setting it up I had to purchase tokens, and I had issues with this, but I'm going to set it up and share with you soon. On the notebook that we'll share, I will have it well curated. But so we'll just walk through this part where up to this point, we have our multimodal retrieval system working. But now we want to end up with a recommender system, which is more robust. You can ask more comprehensive query, like I need suggestions for a flower bouquet for a birthday of my friend, okay? Or a birthday of my boyfriend or your husband or your wife. So that is how you make it more robust, okay? So we'll just walk through this. I'll not execute it. I had issues with my GPT-4 account tokens, but I'm going to set it up and on the notebook that we'll share, but let us just work through. So we're going to use the GPT-4 or model because it supports vision, okay? So it supports multimodal queries. So when selecting which multimodal to use, you really look onto your case, okay? So it's a vision model. So GPT-4 really supports vision, okay? And that's why you set it up here, okay? That's the model you're going to use, and the temperature, okay, set to 0. And then you also, there's a format, you have to instantiate the output parser and also be able now to define the prompt template. When you define this template, that's where the retrieval-augmented generation comes in, the RAG comes in. This is where you define it, okay? That you look onto this template and define what kind of queries that you're going to accept. That you are a talented florist and you have been asked to create a bouquet of flowers, okay, for a special event. And that event can be now defined by the user. And you have to answer the user question using a given image context with direct references to parts of the images that are provided. Maintain a conversational tone. Don't make too many lists, okay? Use Markdown formatting for highlights, emphasis, and structure, okay? And then this is how you define the RAG, okay? And I'm sure there's also a facilitator who will cover this in detail. But you are trying to customize to make sure that the large language model gives responses that are in context. And then you have a user who will type in text, okay? And what are some good ideas for a bouquet arrangement, okay, for a user query? And at times that user can supply an image, okay? And we're dealing with multimodal. The user can give text, can give images, okay? And you have to be able to accept this, up to 2 images, okay? And then now LangChain is the framework, is the link of our vector database, our user's query to the large language model. So you're going to look onto the image prompt or the vision model as well as the parser. Now you have to format these, you have to also, the results that are released from the prompting the large language model, in this case is the GPT-4, because it is multimodal, you have to put into context how you give the response, okay? So you have to be, this is a function that formats the prompt inputs for a given user query, okay? And you have to get the first two images, okay? And you have to encode them, okay? And we use base 64 because that is the format you can convert of, this is the format of images that large language models understand. So you convert them onto base 64 and you are able to get these user query, and you format these prompts, okay? And then you put it all together, okay? And make it user-friendly, conversational. You welcome the user to this flower arrangement service, and you are able to enter your query here. And then that query is accepted, and the results are given as a response. You can get retrieved images, some ideas of bouquet arrangement on your query. It could be a birthday, it could be a birthday, it could be special event. Okay, I want to give a surprise to my friend. But again, that's the main thing I wanted to share with you, that up to this point, you have the multimodal retrieval system working, okay? Now you want to make it onto a recommender system, yeah? When you want to make it into a recommender system, that's when you engage a large language model. And since it's multimodal, you need to look for a large language model that supports vision, and GPT-4 really is very, very good in images, okay? And also the challenge, which I also want to leave with you as a takeaway, is also, this is one case. It's a flower. You can develop a system that you can have a vector database, link it to a language model, and be able to prompt it for a different use case. You can have different use cases, and you can work on your immediate workspace where you work in your domain, and develop a retrieval system and have a recommender system which is more robust. This is a Colab notebook, and which really shows the flow. Is the easiest way to share with you, but you can deploy it on Streamlit, okay? And deploying it on Streamlit, you will not see any of this code. All you'll see are those prompts. Welcome to this florist system, and you are able to enter a query on different flower arrangements, and on Streamlit, you are able to get all that displayed only on a user interface, okay? And you'll have that displayed on a user interface. So I will also share with you code of how you can deploy this on Streamlit and have it as a web interface. So you can have a web service that addresses a certain challenge in using multimodal machine learning, image and text in this case, which I've used. And so I will definitely share it with Anna Grace. This Colab notebook, which shows the code step by step, and also how do you deploy it on Streamlit and host it and have it as a service, as a web service that really is deployed out there. So I will share both of them. And yeah, so that is really a walkthrough that I wanted to share with you on what it takes to develop a multimodal recommender system, that you query using text, you get responses that incorporate images as well. With the recommender system, it's very robust. Once we have the GPT-4 working, you'll have it very robust with recommendation, like this. It can even mention those flowers, what type of flowers they are, because with the retrieval system, we were only able to retrieve the images. I want purple, I want pink. But with having it robust with a large language model, it will even mention what kind of flowers there are. And it will be very, I will share the code, the one that I've used on Column Notebook, but also how do you deploy it to make it usable on a web interface using Streamlit. So this code, you convert it to Python modules, and you have it running on Streamlit, and you have it as well as multimodal case. So with this minimal example that I've shared with you is to give you a motivation that not only do you develop machine learning models, but with images only, but you can definitely combine it with different modalities and have a minimal working system for a case study that you have even at where you work. Thank you so much for listening and inviting me to the IndabaX. Thank you so much.
Thank you very much, Dr. Dina Machuve, for the amazing presentation. Numa, you had posted a question in the chat box, so was it answered during the presentation, or would you like to?
Probably we share
Actually,
names, but
okay, I think someone can share.
probably we shared name, but I tried to answer him. They were Numa, and I tried to answer him. I don't know if he's satisfied with my answer or not. But personally, I have a question.
Yeah, please, welcome.
First of all, thank you for your very informative presentation. And my question is, how do you prevent one modality from dominating the learning process, especially when the modalities have very different level of information density? For example, you have images, you have text, you have audios, and of different imbalances. How do you handle such instance or such scenario?
Yeah, that's a very good question, and thank you for asking. I think it mainly depends on the encoders that you set to use, and there are those different modalities of the temperature, and that's why RAG is very important on a different context in order to control the responses that are issued by the large language models. So that's why RAG is very, very important. Retrieval-Augmented Generator. How do you set it up? That and I showed that prompt that you are a talented florist. And when a user asks this, and for instance, I will share with you how I've used RAG. I was working on developing a farm advisory chatbot, okay? And that uses text only. So I worked with the Llama language model, Llama 3. I didn't work with the GPT-4, which is multimodal, but that is one which deals with text. But I only wanted the responses to deal with farm advisory and only on poultry, not cattle or any other. So it's how you develop that database, the retrieval-augmented generation data set that will definitely guide and reduce the hallucinations on the responses. So again, if it is in multimodal, you will have to have a RAG, a retrieval-augmented generator that really is very specific and context specific to the context. So it's how well you work on developing that retrieval or augmented generator for your particular case. So you can have it, you can have audios, you can have images and text that are related to that subject, farm advisory, okay? So you develop that vector database to be very specific in that context in order to be able to really to reduce these hallucinations and get as much answers as accurate answers as possible. Yeah.
All right. Thank you very much, Dr. Dina. So if there is any more questions, please feel free to put them in the chat box right now, because I'm not sure if Dr. Dina will still be staying or leaving. So meanwhile, Lonnie, are you?
But I really
there?
promise to share the resources through an address. Thank you.
All
Thank you
right,
so
and
much.
so I'll be waiting for the notebook as well as any other materials that you have, so that I can share with the participants by the end of this the 4-day session. Okay, so thank you very much, Dr. Dina.
Thank you. I will do that.
All right, so and as I mentioned to the participants that we're going to have facilitators on AI tool challenges. Before that, we're going to have someone who is going to give us insights on building AI with open source, because if we're going to build the tools, we have to also speak about how how exactly we plan to build them. So Mgasa, are you in the room? Mgasa Lucas.
Hello?
All right. All right, nice to see you. Yeah, so I'm going to welcome Mgasa Lucas, who is going to present about building AI with open source. He's a co-founder from Quantum Intelligence, but I'm also going to let him start by introducing himself and then kickstart with his presentation. So I think we have about 20 minutes, Mgasa.
Okay.
So karibu sana.
Asante. Can you see my screen?
Yeah, sure, it is visible.
Good morning, everyone. Am I audible?
Yeah,
Yes,
good
yes,
morning.
you're audible.
Exactly.
So quickly, my name is Mgasa Lucas. I'm the co-founder, and I can define myself as artificial intelligence entrepreneur, and I'm here as the business developer from Quantum Intelligence. So we are here for Tanzania Deep Learning IndabaX as the part of the local chapter towards the continental gathering that will be happening in Rwanda for the next month. I'm also proud that I'll be among the participants in the Deep Learning Indaba that will be happening in Rwanda. So, and I'm very proud to be invited here, sharing a bit of what we are doing and sharing a bit of our own perspective around what it takes to build AI solutions, particularly by using open source solutions. So AI keeps accelerating, and in a brief, I just want to talk about some of our efforts in building these technologies or involvements where we want to enable anyone who wants to build AI solutions to do that faster, maybe with minimum resources and all of that. So briefly, just a background about myself, I have background in computer engineering and a bit introduction about Quantum Intelligence. Quantum Intelligence is artificial intelligence research and product company, where it's a team of data scientists, software engineers, and machine learning practitioners, where we are working with some of the businesses in our ecosystem, trying to build AI solutions and data solutions. We came to realize that it's very hard to build these solutions, speaking to the human resources, speaking to the even monetary resources and all of that. So we are building a company as the research company, but also building the product company around that space. So we truly understand that it takes a lot of effort to build AI solutions. And speaking to the infrastructure for the AI, to build an AI solutions, for us, we believe there are the three pillars. There is the data pillar, there is the algorithm pillars, and the computing pillar. for any company, when you want to build any AI solution, for example, data is the fuel. So you need maybe clean data, you need relevant data so that you can have the accurate models in the algorithm that they can learn from those data in a more accurate way. So there's also companies that are building algorithms, which is the part of brains for the AI systems. There's also companies that are more focusing on computing power, where we need the raw processing power to train those large models on the huge amount of data sets. So among all these pillars, for us as the company, we choose more to focus on data side, where we are working with some of the businesses that I could share later, helping them in the cases of data analytics, trying to understand maybe what do their customers like, why, where are they coming from, and what are the risks that may happen if the customers maybe are churning. So we're using some of the open source technologies to do that. So speaking to the data side, we as a company, we are focusing more into two sides, where we're working with companies that they need services around the data annotations or data labeling services, whether they could be researchers or whether they could be AI company that they need those services in that space. I could share what does the data annotation mean and what are the tools that we are using as a company later on. So what does quantum intelligence does? I could bring you to our website. Yeah. Can you still see my screen? So as a company, our main focus has been helping companies or other businesses to adopt data-centric operations. And part of the service that we are offering services around building customized AI solutions, but also we help other companies in the DevOps side when they build those AI models or when they build maybe whatever tools that they need, maybe in the data processing side, to extract data, to transform it and to load it into different processes, maybe to gain those insights. We are offering services in the areas of DevOps, but also we have one of our products, which is called a deep operator, which is the tool that is used to help other companies for the process of data annotation. Data annotation is the process of labeling data that are going to be used for training machine learning models in a more accurate ways. So during that process, we're working with them maybe in the space of collection, but also space of labeling those data. The other thing we are building, that's the same tool. It is used for data analytics, where we are integrating with the tools like Power BI for the part of analytics to enable it during the process of understanding those customer behavior and building those analytics tools. So for more information, you can visit in our website, looking on what we are offering and having just a brief, if we could need any kind of services, maybe, or any kind of partnership, we are also looking toward that. So coming back to the slide. So as I speak earlier, we as a company, we're working as the middleware between those companies that they need AI solutions as a part of business analytics or data analytics side, but also building the software solution that are added with maybe the integration with different APIs to integrate into their operation and stuff like that. As I mentioned earlier, the infrastructure in building those AI solutions are more integrated into three pillars. The computing side, we know some of the known companies like maybe NVIDIA, AWS, that they offer those services. So if we could look as the company, we see ourselves speaking to the company like maybe Scale AI, focusing more into the side of data, where you're helping other companies to build like data. Hello? Hello, am I audible?
Hello, Lucas.
Hello.
Lucas,
Yeah.
yes, we can hear you, Mgasa.
Yeah, we're working on the side of building those like data infrastructure for other companies so that they can understand their business insights and other companies that they need data to be able and stuff like that. This is the side where we're working with this, researchers when they maybe need to collect data and to transform it to more accurate data models. The other thing, we're working with the businesses, as I mentioned earlier, speaking to the data analytics. Whatever maybe the companies, they have like digital tools and they collect data. There's the side where we are helping them to understand the operational analytics, to optimize, for example, the internal processes and to boost the efficiency in the operation. If they have a certain product here and they need maybe to understand what are the features do customers most likely, what are the features that customers don't like. Maybe if there's the customer that are churning from their product and stuff like that, what are the reasons behind for those challenges. We're also working into areas of understanding maybe if there's issues around financial planning. For example, you have a product and you want to understand maybe in your business model, if you're selling a product and you have different, for example, different packages in your services. If customers are buying a certain kind of package more than the rest, what are the reasons behind? And what are the trends maybe from time to time in understanding that, that kind of behaviors using data. So in these processes, most commonly it is done maybe with the data scientist, but we are doing it as the partners. We can partner with a certain company and we help them into those processes as an external partner. The other thing that we are building it as a product, it is called Deep Operator. Deep Operator, it is the tool. It is the tool that is used by data scientist teams for the section of data annotations. So generally, if you want maybe to build a certain kind, maybe a model to detect, for example, let's take an example, maybe a disease, for example, pneumonia. You have a lot of X-ray images, taking it as an example. Those images, they can be normal images. Some of them, they can be images of a certain disease or images of for example, the pneumonia specifically for it, it can be the pneumonia of the different types. So some of those data, they are not accessible online, for example. So if you have a problem of that case, and you are a researcher, for example, from the medical side, or you're the company that is building those kind of solutions, you have those images, but during the process of collection and labeling those data, so we are outsourcing it as a tool where we are collecting those data and giving those point to the annotators, and they enable the process of labeling those data to enable the output after training the specific model, perhaps to be more accurate. So that annotation is one of the very crucial aspects in machine learning. So if you remove for example, if you remove the garbages that exist in data, if you make your data more accurate, we actually expect your model to be more relevant to what is expected as an output. For those who don't know, maybe data annotation is the process of labeling or tagging relevant metadata within a data test, so that we can enable machines to interpret the data accurate. So in building this as a platform, and currently we have one client who use it, and we're trying to validate exactly the way it can be scaled in other industries. So during that process of labeling and tagging specific data, so that we could enable the machine to interpret this data accurately. And we understand that this is the main problem, because if you want to build AI solutions or any kind of a model, for example, more than 80% of your time, it could be taken during the squaring of those data, during processing of the data, and annotation processes. And this is where most of the time where machine learning engineers are spending to do those activities. So the challenges are there is lack of good tools that can be used during those squaring processes of data, but also most of the processes we are using spreadsheet, for example, and it is difficult to manage. So we are building a single platform where we can manage those processes and outsourcing those activities to the specific annotators. So the majority of time being spent on not on the model training, we need to optimize in helping them, focusing more on machine learning aspect and experimentation to get the more and good output. So key features in this platform, we are annotating data into mainly three formats: text, images, and tabular data, and logs data as well. So what actually we do, we enable end-to-end data management processes where someone can connect a certain data source and feed it to the system. So to extract maybe the certain kind of information. And after that, we outsource it to the specific annotators where they can do the process of labeling those specific data and to make it more more accurate, specifically to the specific knowledge that is required in that aspect. And later, after the process of annotation, we can get into and helping them for the section of building maybe the specific model if they don't have expertise in that space, and to enable them doing that processes. So the workflow from step to step, the first section is just the process of data upload. After that, we have the data injection processes, and someone has maybe to create a project and assigning it to the annotators, so that annotators, they can start to label those data and to track progress as well, and to manage everything smoothly. So once those processes are done, the labels that have been made and the process of training will begin after the data has been labeled correctly. So we have a demo. So achievements so far, we have been working with some of our partners in our ecosystem. I don't know if some of them are here. We have been working with companies like Zindi-Sartify in the process of data collection and labeling those data. Specifically, it was in the case of text data. I don't know if Dr. Mollel is here. He can also share the testimonial for what we have been working together. Is Dr. Mollel available here?
Yes, Mgasa.
Yeah. Zindi-Sartify is one of the companies that we have been working on the process of collection of those data, text data, and they use it as being part of our partners. We help them in collection of those data, and we give them for the process of the operation. The other companies that we are working with is Swahili's. We are using the same platform for the processes of analyzing the behavior of the customers. What do the customers like? Perhaps what are some of the customers maybe are churning from the services, and if maybe sales of the revenue drop, what are the things they can be improved based on the previous behaviors of the customers during the operations. Out of the companies that we've been working, we have been working with some of the individuals researchers to build those solutions, and particularly maybe people who are doing masters, for example, people who are doing PhD and stuff like that. So speaking to the open source, and why has it been very important for us and even for the AI ecosystem around the world. Open source, with its own definition, is the software which its source code is freely available to anyone, maybe to view, to use it, or to modify and distribute it. These movements around building the open source softwares and technologies, they started late in the years of 99 from there. So it was mainly inspired with the development of the open source software like Linux and Apache. And to be honest, artificial intelligence, as it for now, it is one of the technology that has been accelerated very faster using the open source technology. But the core goal of open source is to enable collaborative innovation, to harnessing the power of communities around the world to build reliable and securable, maybe scalable technologies. It is as it has been happening in the Linux, for example, side. We know things like TensorFlow. We know things like the transformers in Hugging Face. All these are the technology that has been done and being enabled using the open source technologies. And even from our side, for most of the stuff and most of the solution that we are building, basically we're using many of open source technologies, TensorFlow, PyTorch, for example, even Power BI, open source tools, and all those related technologies. So in AI and data solutions, open source has been enables us to accelerate development, maybe reducing the cost and ensuring we have a small team that can build faster and iterate responsibly during the process of building those solutions. Among the notably open source solutions that I think for any AI practitioners, they can actually have been interacted with it and use them. It's like TensorFlow, we can take the example of it. The tools like PyTorch, Keras, and others that has been developed by other research organizations from outside the world, and they have enabled us, even the local developers, to build those solutions on top of us. Out of those, we have some sort of initiative in Tanzania, which these are just the highlights among many, which are the open source tools and software that has been developed. They are open for anyone, maybe to do the contribution, speaking to Twiga, which is has been discussed here, with the WhatsApp chatbot designed for Tanzanian teachers to build education experience for educators and having them the access to generative AI solutions using retrieval-augmented generation. Data from Nile AGI, it's also one of the local AI tool that enables inferencing in the models for anyone. Maybe you have computers with the CPU capabilities and all that, to have access to the high capabilities model in a more efficient way, and enables those AI capabilities even on the low resources hardware. We also have PySwahili. It's one of the open source technology that has been used in our ecosystem. PySwahili is the Python version, but in Kiswahili. So it was particularly built to allow Swahili speakers to get started with programming around Python, even without having maybe the and stuff like that. So artificial intelligence actually wouldn't be here today without the existence of open source. Regarding maybe, for example, with the competition that currently exists between the companies, maybe the countries, for example, USA, China, and maybe some countries in Europe and all around the world, open source has been one of the things that has been enables even maybe the small teams around globally to build these AI solutions in a more cheaper way. And if it could be harnessed in our country, taking as an example, it can be an enabler for most of the people to build those solutions in a more efficient way, in a more open way, and stuff like that. Even for those who have been following on the America AI Action Plan, one of the key pillars that they have been discussed very much is on emphasizing the use or the enabling process of the use of open source technologies or open innovation, so that anyone can build those AI technologies in a more open way. So for a bit of my presentation, AI has been potentially, or we believe it could be one of the most important and beneficial technologies to be ever invented. So we as a company, being as one among the startups in AI space in our country, we have some of our efforts internally trying to enable that anyone who wants to build those AI technologies, we could act as the middleware, for example, with other AI companies, speaking specifically to the areas of data annotation side, or working with other companies that they need maybe services in the space of data analytics and stuff like that. So that was a bit on my introduction and the presentation around open source and some of the tools that there have been used and some of the open source technologies and tools ever built in our ecosystem.
All right, so thank you very much, Mgasa, for the amazing presentation. I don't see any questions in the chat box. So to participants, if there is anyone who has a question, you can raise your hand.
Juma?
Oh, there is a hand? Yes, Juma. Juma karibu.
Okay, thank you. And thank you, Mgasa, for your very informative presentation. I was so curious on how quantum intelligence do, and you already cleared up my doubt. But I have one question: is you said you provide the solution on labeling and all stuff comprises of about data. But my question, who's gonna store that data? Are you a company that store a data, or someone else in the middle? And where does those data, for example, they being stored in let's say AWS or Google Cloud, or where do really this data being stored in?
So our platform actually, it is hosted in these cloud service providers. We mostly use DigitalOcean. So those data, they are stored in the cloud, but it comes in different ways. There are some of the data that they need more concern around privacy. For example, maybe it could be data in healthy sector. So it depends with the kind of clients or the kind of customer that we are working with. If they could need data to be processed in the platform locally, we could do that locally. But if they need to be processed using cloud services or cloud service providers, we also do around using those cloud solutions. Yeah. Did I answer your question?
Exactly. Thank you.
All right. So I'm just looking for hands. I don't see any other hand that is raised. So thank you very much, Mgasa, for the presentation. And this marks the end of our session 1 for today. And as per the program, we are now going to have our breakfasts. And then we're going to resume in 30 minutes. So I hope everyone is going to be back by 11:30. So that means like 26 minutes. So I really hope that we're also going to be on time.
Sorry, Anna. I think my timetable is different. I think.
Oh,
Sorry, Anna.
am I missing something? Just let me check. So Mgasa, you're the one who said your timetable is different.
No, I think we are in the right time. I was supposed to present from 10 half
Yes.
up to yeah.
Yes,
But I
we
see
are
the
we are
few
on time.
questions here.
So mine is from 11 East African time. Anyway, but it's okay. But I think my timetable show like I'm supposed to present now after Mgasa soon. There's no break on my schedule.
It's Dr. Mollel speaking.
Yes.
All right. So I'm not sure the timetable that you have if it's the most updated one. Let me just get to you.
Dr. Mollel,
Yeah.
I may have sent, that might have been the one previous to, I think we had a adjustment. Sorry about that.
Okay. Perfect.
But I think you're presenting right after tea break, right?
Right.
Mine show is 11, but it's okay. I can present after.
Yeah, sorry about that. I'm not sure.
All right, apologies. We're going to send you the updated version as well as the WhatsApp channel link so that you can have all information right on time. But yes, so thank you everyone. So let us quickly go for break and then resume at 11:30. And Mgasa, you can just stop sharing your screen now.
Okay, thank you. I see there's a few questions here. The other one asking for the data makers, are they Tanzanians? Yes, basically we are based in Dar es Salaam, Tanzania. We are at the Costec building, Science Kijitonyama. Those are my contacts. You can also visit in our website and you can reach out me anytime and then we can give more information about our company. Thank you.
Hapa karibu na nini hapa? Karibu na begi, unajua vile kama kitu fulani. Naomba tukeni check. Kwa hiyo sidhani kama itakuwa convenient sana kwako, lakini basi naona itakuwa mambo mengi, lakini kile
start building tomorrow. No, tomorrow won't come.
Yeah, I remember your quote from yesterday, but that scarcity necessitates innovation, right?
Yes.
Just build. Yeah.
Just build.
So
build. Don't have an excuse.
yeah. That's amazing.
So if I take just a little introduction of a competition. So this competition is at Certify, we are building different models, actual models. So and we started with the big models, and now we are going for on-devices models. So on-devices model, we wanted to make it open sources models. So and also once you make open source, we want the model to be usable. You can have open source, but the model is not usable. You can have DeepSeek, 600 billion parameter, but no one will use it. I mean, only big companies, so there's no use of it. So we believe everyone can own their own models. And one of the models which we think is imperative to our life is a speech to text. We have a very good one, but it's very big, and we don't want to make it open because no one will use it. But the smallest one, we want to make it open source. So we want a community to contribute. And so we collected very, very good data sets, almost 7 hours. So the data set came from actual court. Another data set came from the classroom, actual classroom. Another data set.
This is in full Swahili, right?
Full Swahili. Full Swahili. Another data set came from classroom, farm, court, and another just spontaneous recording. So this is the data set we use to evaluate these models. So very unfortunately, I've seen only people not from Tanzania who participate or they submit the solution yet. But I can see a lot of Tanzania joined the competition, but none of them submitted. Just try to submit, and then you feel it. Especially you student, you can form a team, you can submit a competition. Believe me, we have achieved one of the best results. And just imagine from Certify, is only 2 people work with this model. So I believe you student, if you have very good team, you can achieve very, very impressive results. As far as now I can see, there is still a big window to optimize the model or develop the model, because we know we have benchmarked ourselves, so we know like this is nothing. So you just need to find a few tricks and tweaks, and then you can beat our benchmark itself. Yeah, so this is a competition. It's called Your Voice, Your Device, Your Language Challenge. Is a proud sponsored by Certify company, and you can find on Zindi competition. The winner would get more than the pool of winner get more than 3 million Tanzanian shilling.
Wow.
And there's a high chances we are still working with ITU if we can take the winner to Geneva next year, but that's not confirmed.
Wow.
But,
wow. Okay.
Yes,
well,
and yeah.
It's good that you're saying this now, because I think in these few months, and the deadline is when? September, right?
Yes, September.
So most students in university here are on break, right? During their likizo. So they have time, get together as a group, work remotely, and submit something to this. Because even the experience will be worth it, right? To learn about how this works.
Yes. And anyone who wanted to know a few things about the competition, you can go to our GitHub, Certified GitHub. And then in Certified GitHub, you'll see we put many details about the competition.
Okay, can I share the link to the group?
Yeah, I'll share 1 minute.
Certify or your personal?
Certify.
Okay.
Yeah. So it's called Swahili Challenge Competition, Pan-Africa Wide Alignment, blah, 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 ACR Challenge. So we put introduction, where to start, what the data set you can target, and a lot of stuff here. And how to do evaluation. So our code is full, for starter, you can just pick a few of them, and then you can work on this competition.
Wow.
Yeah, so you can share, please, Ronnie, the Zindi competition itself, the link, and the GitHub. It would be great.
Yep, I'll find it and share it shortly. Great. Yeah, thanks for emphasizing this. Big opportunity to learn and even win some money. Yeah.
Yeah, and some money, and probably a trip. It's worth it. Trip. I mean, it's
100%.
Yeah.
Okay, so welcome back to Mollel to introduce us to SLMs in some detail. Welcome back from yesterday's introduction to PAWA, and you're going to go into more in depth about how this model works, right? Karibu sana.
Asante sana. So I think yesterday I was here, and to reiterate, my name is Michael Mollel. I have some background in machine learning and AI, and actually telecom. I'm telecom guy. So anyone can do anything nowadays. So my PhD was based on the using of reinforcement learning to optimize the system in telecom, actually. Yeah, so you can find my LinkedIn profile if you scan the QR code, and we have worked with a few products from Zindi-Sartify, which is this competition, for example, where we develop ACR, which we call it Kinongono, and our team from both partners, Voice AI, and as we think, okay, Kinongono is too complex, so maybe we'll change later. And PAWA is another product which we presented yesterday. Just nutshell, but later today, someone from Zindi-Sartify, actually co-founder, will come and explain more about it. Competition. Yeah, so so today I'll just take you through small language models, and actually we have been working small language models for quite a while, and I think it's nice to share what is the actual small language models. So there's no like actual definition like where to distinguishing between large language models and small language models, but just it's philosophical term still. So as a general rule, we can say it's a compact, very efficient version of large language models. So if you see from the right-hand side of my screen, you'll see assumes the neurons. So the neuron, you'll see it's so big, like too many neurons. I don't know, too many neurons, but the smallest one is like a small version of the neuron. So the top neurons you see is how many? It has 1, 2, 3, 4. It has 4 layers, and depth is so big. But the smallest, the right-hand side, the one in the down one is a smaller neuron. So consider there's the big neurons and the small neurons. So once it's big, we call it language models, and one is small, we call small language models. So if you count these neurons, so neuron is just if you count them, so if it's more than, for example, 10 billion, we can call it large language models or large models. If it's less than that, we can just call it small models or small language models. And actually nowadays there's something called tiny language models, and there's now another term we call atomic language models. So it still there's no clear like boundary to differentiate between this, but in rule of thumb we can call, okay, less than 12 billion parameter or 14 billion parameter you can call small language models. Above that you can call language models. And also there's a massive language models, like we don't know, like ChatGPT 4.5, I mean ChatGPT 5, or we don't know. So we call massive language models, but no one knows the actual parameter of those models. So key characteristic is the number of parameter, which for this case is less than 10 billion parameters, based on my definition, but someone can say, okay, less than 14 billion parameters. And another important thing from this small language model is very efficient in terms of computation, because they are small, they can even fit to any devices, your phone or Raspberry Pi, you can use for different application. What distinguishes from these large language models is small language models, most of the time they are very, very focused, task focused. So you need to focus on specific tasks. For example, if you are doing a classification of between malaria or no malaria, that's where this small, you can get the best of it from small language models. So actually it's balance between the performance and efficiency without sacrifice much capability. So capability is general. So we know general models like ChatGPT, they're very general. They can answer any question or most question, but if you go for smaller, you won't get the feeling of the big models. But at least if you specify your task, yeah, you can achieve the same performance. So what is the problem of why we need small language models, and if they are not capable, right? The issue is our phone has a limited power and has a limited computation resources. So when I say computations like CPU or chip, the phone can support it. So in order to take your brain or these models, LLMs models, and to fit to these chips, at least we need the model to be relative the same size with the chip. So most of us, our phone maybe support maximum of 12 GB. This is RAM, so that is the RAM for everything of your phone. And just assume the equivalent, you have GPT-4 and you want to fit in your phone. GPT-4 has, let's say, 1 terabyte GB, terabyte, and then you want to fit on 12 billion. That is like you take a bucket and you want to fill a bucket of water and want to pour on the cup. You expected the water to be spill off, so it won't be possible. So for that case, we need to make equivalent size or smaller than the capacity of the chip. That's why we need to make sure we have small language models which can fit on the devices. And another thing, big model actually use higher computation power. So our phone is limited power. So if possible, you can fit these big models. Still, to learn model, you need massive power, and our phone is limited in power. So still, this is a problem. So actual small models, they are very perfect to smartphone or tablets and IoT devices. So if you are doing any project for IoT or smart or tablets, I'll consider you guys to look for option for using this SLM instead of LLM. And believe me, I don't have problem with the cross models, but as a researcher, don't go there. Don't go that direction because it's very expensive to learn cross models. And if you small model, you can achieve the same performance. Why don't you go for this open source models, especially if they're small, so you can able to do your complete end-to-end application based on what you have or computation. And most of the time, the people they said, okay, no, we don't have GPU. We have something where we can learn this. It's just we don't want to explore the options. Yeah, so another problem is research intensity and inaccessible to many. So this GPT, they are very, very resource hungry. They eat a lot of resources, and I don't know, none of you have been deployed any application in the cloud. You find it is very expensive. Yesterday I showed you guys just 2 days or 3 days for us training this power model, we consume more than 28,000 US dollar. 28,000 US dollar is more than 80 million Tanzania shilling, and that's just 2 days. So I think most of us we can't afford that, and for that case, I would advise us to go for SLM or tiny LM or atomic LM. So there's a different now nomenclature of these LLMs, but for now I'm strictly defined on my bound of SLM, which is any model less than 12 billion or 10 billion parameters. I already mentioned is a very resource intensity, and so another advantage is easy to fine tune. So if you want, for example, if there's open models available online, and you want to customize to your product, if you get 2 choices between bigger model and small model, I highly encourage you to start with small models. Provided you have enough data and enough technical, you can able to achieve to do the model to do a specific task. So it is easy to fine tune small models. There's a different techniques, QLola and other we call spectrum. Many techniques available for you to fine tune. So we at Certify actually we fine tune this any model, especially open models, and we give the companies and actually do for their product. So I think most of us just know chatbot, but that's not all about AI, guys. AI has scope of different applications. And if you start the business case of any company, that's when you realize, okay, I need this here to do AI and this to do AI. But not every problem will be solved by AI, but at least most problem can be solved by AI, right? So you just need to explore and try to see what's the business case. So these small models, most of the time they are very fine-tuned to specific tasks, and once you do for specific tasks, they are very good. But if you do for general, like PAWA 2 billion, we did for general, they might not look good, but it's good for specific use case, and I'll show you some just 2-minute demo. And also why we need still SLM. So if you have limited budget in terms of computation power, you need to access this model still, but you need at least your model to have very low latency. So when I'm saying latency, is the speed on which you get a response from the from when you query. So these small models, most of the time, because they're small and they can run fast on any GPU or CPUs, the time of response is very high. And for that case, user experience will be great. And that's why we need SLM instead of LLMs for most of this kind of applications. So definitely how this works. So how it works is not quite different from how the language models works. So they work the same way. So they use next word prediction, most of this, except from there's new architecture which we call multi-token prediction or diffusers prediction tokens. But in nutshell, let's call the same architecture on which they're using LLM. So we use something called next word prediction, where it analyzes the text and then try to predict what will be the next text, right? So example, the name are as follows: Michael, Ronnie, Anna Grace, and what next? So it will predict what is next from the name. So this we call masking. So we mask what will be the next output, and we try to predict what will be the next output. And then we do something, we call it, like, I guess everyone knows this, I have at least a little introduction about how this deep learning works. So we try to maximize the objective function by trying to minimize the loss of what you try to predict and actually what is predicted. So this is kind of semi-supervised training on which you just masking, but at the same time, you already know what will be the output and try to minimize. So once you predict the next word is Juma, and actually the next word is Juma, you give very good reward. So entropy will be 0. And for that case, loss will be 0. But if you just wanted to predict Juma and just you say Lehema, that means bad. So the loss will be high. So it will be 1, right? So this is how SLM is not quite different from LLMs or any AI architecture. Most of the time we try to optimize what you want to predict. And also our objective functions is try to develop what will be the next word and try to see if what we predict and actual word is the same. So in LLMs or any AI, we call these tokens most of the time. So yes, for simplicity, I choose word. So it's based on transformer architecture. So transformer architecture is based on self-attention mechanism, whereby each word is attention to another word within the sentence. So we call longing independency of the words. So when you say my father is a hero, there's a high chances when my father is hero has very good attention or relationship with my father, and that's when human being interpret. So we don't just interpret word by word, but we interpret attention of the words between words. So we call this cross attention. So basically, the idea is the same, to identify the relationship between the words and to distinguish the meaning based on context. So when you distinguish the meaning between king and queen or he and her, that's how this works. So size and performance balance. So SLM, they are small. So technically, they are less in computation cost. And because they're small, they are fast in processing. So it's almost a real-time application. Specialized performance, most of the time we specialize for domain specific. And one of the use case or SLM examples is a power min. I'll show you later. So power min is 2 billion parameters, open source, and it's scalable. You can use it. I'll show you one use case, small use case. Another is Llama 3.1 billion. I can say one of the best Llama availables is Llama 3.1. It's very good. Any Llama 3.1 people can use it. And also there's a Tiny Llama or any Vicunas or whatever you can get. You can use it. Yeah. So how to create these SLMs? Is this different from LLMs? Yeah, it might be true or not. So you can start by training from scratch. You can choose your own architecture. For example, let's say you choose Llama 3.1, 2 billion or 1 point something billion parameters, and then you can do the same procedure as how you train these LLMs. So you can choose LLMs. You can use dataset. So I have to recognize a few companies in our partners. One is Quantum Intelligence. They provide us sometime data. We're working with them, me and my team from Certify, and also we work as an independent team sometime. So for this data stage 1, they help us a lot, and guys, I will advise you if you want to look for that, you can look with them. And also in terms of computation, I want to recognize University of Dodoma for providers GPU and computation. Actually, we're working together again with them also. So you choose your LLMs, and then you use your data, you apply attention mechanism. So we call this algorithm. And then we do something called pre-training. So you start by pre-training. Pre-training is when you try to minimize the next word prediction. And then once you're done, you create something called foundation models. So this foundation model actually will have the knowledge of what will be in next word prediction, but it's not useful as it is, right? It's not useful as it is, but so to make it useful, you have to perform another task stage, which we call supervised fine-tuning. Even though nowadays there's too many architectures, so this is just a basic architecture I'm giving you guys. So you do something called SFT, which is supervised fine-tuning, and once you're done with supervised fine-tuning, you are going for alignment. So alignment is when you align the human value or LLMs or SLM to do as human was supposed to respond this. Like you remove head speech as much as possible. You try to follow the instruction and other stuff like that. So that's one way of creating SLM. So you choose very small architectures, and then you do the same procedure as LLM. Another technique we call knowledge distillation, and recently we submit a paper for knowledge distillation in Nature magazine. Actually, it's Nature Communication, Nature Engineering. So idea is to use a teacher and student model. So you have very big model like GPT, right? And then you can have a very small model like PAWA, and you want it to transfer knowledge from GPT to PAWA. So there's a different techniques like response basis, feature based, and relation based. So response basis, you can use something we call it soft distillation, whereby you have few questions and then GPT will answer them, and then use that answers to train your small models. So it learn how GPT responds, and then eventually to become great. So idea is to have small models where it try to, as much as possible, to return the accuracy of the model itself, of the base model or big models. Another technique to make this small model is to use pruning. So pruning is you have very good or big GPT. For example, if I've been given GPT 1 trillion parameters, I can't run on my devices. What I can do, I can just prune. I can just choose which layers or which neuron I can remove. There's a different technique we call spectrum. So you observe which neuron has high signal to noise ratios, and then you target those with high signal to noise ratio, because even though you're going to reduce the high signal to noise ratios, but still you maintain the knowledge of the previous models before you prune it, and then you trade off, because the high signal to noise ratio it focus to the specific domain, so you want to add another domain. So once you prune it, that means you remove some neurons, and then you perform a distillation or another techniques of fine-tuning in order to maintain the performance. So you see the left-hand side is the LLM, which is so big, and then when you prune it, so pruning is like you cutting some neurons, and then you end up with a small LLM. I guess you see my screen. Yes, another techniques which actually is not making small LLM, but at least to make the model learning as a small LLM, we call quantization. So quantization is normally parameters you can have the same parameters. So you see my left-hand side, you see that there's a matrix whereby there's a 4x4. So consider each box is a neuron. So you have 16 neurons, right? And the middle also you have 16 neurons, and the end you have 16 neurons. So you don't change any parameter. So still you have 16 neuron parameters, but each neuron will be presented by how much digits. We call these frauds, right? Or precisions. So by rule of thumbs, based on engineering, we assume like if you present anything from 32 bits, that is when you achieve maximum message carriage information, right? So that is the rule of thumb, but it comes with a cost. So if each box contains 32 bits, so that means 32 bits times 16, you can have much bits. But what if we can reduce the bits instead of presenting each number in 32 bits and present number in 8 bits? So once you present in 8 bits, you can have small memory, and that means if you have a small memory, you need a small computation time, and the speed will be high. So this is not actually creation of SLM, rather than to mimic kind of to cheat, like to use it as a proxy to quantize a big model to look like small model, but actually it's not small models, but it will be the same parameter, but at least it will learn fast and efficient as a big model. So the right-hand side, you see if the above, you'll see kind of Bernoullian curve, normal distribution kind of. So this is just a simple way of mapping high precision to low precision. So you can just distribute your numbers, and then once you distribute your number, you can just map your quantized level you wanted, and then you can just map any number in binary distribution to the number reflecting the smallest number projection. Yes, so this is the quantization, is kind of techniques of making SLM, but actually it's not SLM, it's just a cheating kind of making SLM look like SLM, which is small language models from big language models. How good is this LSLM compared to LLM? So LLM, in nutshell, they are very complex, as we mentioned earlier, because it contains a lot of neurons. They are very sophisticated in terms of follow many instructions, and they can answer to any general task. They are very good. In terms of SLM, they are very simple because they're small neurons and more focused on specific tasks. And once you have very specific tasks, don't go for even ChatGPT or OpenAI, you pay for nothing, because it's very simple task. You can just fine tune SLM and can achieve the same performance as GPT. And we done that, actually. We have some of the company, actually the government organizations, they use this SLM for their product and for their business case, and they're very satisfied with it. So this is the proof. LLMs, they are very deep understanding in reasoning, because it has a lot of neurons. They can process a lot of informations, and the long context, because it has very big neurons, so it can carry distinct values and information passing. And actually, these LLMs are better accurate in every kind of tasky. And yeah, so as you can see, I show you a picture of someone with a very big cake, and then you can slice to the smallest. So once you slice the smallest, that's when you get the small LLMs. It's very focused. It's very domain specific and specialized application. So if you have very good specialized application, you don't have budget to run on cloud or big GPUs, as most of us, we just give this a choose, you can go for SLM. Yeah, so in terms of resource constraint, you need most of the time specialized GPUs to run these LLMs, and to be honest, guys, it's very expensive to do this. I don't know if any of you have hosted one of these LLMs. They are very expensive, very expensive. While by SLM, you can even use a consumer hardware. You can run this on your own devices. You can use Raspberry Pi to run this. If you have a different project, you can use this. I'll show you just a few small demos, and then to demonstrate this. Later today, my colleague from Certify will take you through some what we call it challenge tools, and then you can get a high feel of how to build these applications. Yeah, so LLMs are very best in cloud because as far as I know, someone can correct me. I know very few GPUs, and all GPU are now in University of Dodoma. HPCs are not GPUs, so you can have HPC, but it's nothing. Like in LLM space, it's nothing. Like and those GPU in Dodoma is not even enough to learn like full training of this any moderate LLMs or SLMs. So we still have not concentrate too much in LLM. I would rather say, okay, we should concentrate much in SLM. So SLM, you can able to even to use edge application. You can deploy yourself, on your computers. There's many tools or llamas which can learn on SLM or mimic the SLM kind with quantization. And they are, in terms of latency, they're very good. So user will have a very good experience. And if you fine tune well, yes, you can get a very good performance. And at Certify, we do that. So if you have any problem in terms of want to do fine tuning, or if you want to do deployment of LLM or SLM, we can do for you and for your organization, because this is what we expect, like in terms of deployment. So choosing between SLM, when to choose this? If your task is very complex, definitely go to LLMs. But if you are focused on specific task, SLM will work fine. Don't go for fancy, like just for the case of I'm using ChatGPT or API. No, don't go there, because small task, you don't need high machine to do small task. You can even go for the SLM. It can work fine, provided you just fine tune it and try to try to optimize what you're trying to achieve. In terms of resource availability, so if you are GPU rich, too much resources, and you don't care about power, right? Just go for LLMs. You have little to do, like you can just plug and play API. I may call the vibe engineers, whereby they only know about API. You can be, I don't have a problem. I keep saying this. You can be very good on what you're doing, but I don't think that you need to claim your ML engineer or AI LLM engineer, because you just use API. You are more of developer side of it, which is fine still. But if a GPU rich, you can just plug and play, use API, that's fine. If your deploying location is based on edge, okay, definitely you need SLM. It's not about option of you to use LLMs, but because you can go to village and still don't have internet to connect to this cloud LLMs, still you need SLM to run on your devices. So this also reflects to the internet connectivity. So if you don't have internet, that's mean you definitely need SLM instead of LLM. And another thing which is very important, guys, and I keep saying this, the future is open source SLM. And this is why, because if you are doing any industrial applications, right, everyone want to protect their data. If you are doing any legal application in government, for now, maybe they don't know, so they might tolerate, but sooner or later, they'll realize, okay, our data, all data goes to US in OpenAI. All our data goes to China, to DeepSeek, for example, or now there's a Zap, right? So soon, once they realize, like, data is gold, data is oil, definitely everyone will go for open source, especially SLM. So that's why I'm encouraging guys to do most of SLM instead of LLMs, or use more for your own API instead of using cloud API, because the future will go there. We necessitate us to go there. For now, yes, this AI boom, everyone will go for API, make a good first application, but in future, everyone will come to realize, okay, my data is going to US in terms of Silicon Valley, and Silicon Valley will know everything from my side, and then I'm nobody. Right? It's like you don't have clothes, and that's, if you don't have clothes, you are nobody. Nobody. You're nobody. That's the issue. So latency requirement also necessitate to see between or to use between LLM and SLM. So if you have latency issues, and for some reason, if LLM is very fast, still you can go for LLM because it's very accurate. But if you have latency issues and you want on devices, definitely go to the SLM. And SLM most of the time has very good speeds in terms compared to LLMs. Yeah, so just how to use, for example, this SLM, as I keep saying about SLM. So how to use this LLM. So for now, you can just go to Certify website. For Certify website, we see we host this model, which we call PowerMini Alpha. So PowerMini Alpha is open source. It's 2 billion parameters. And if you go there, you get a model card, and you'll see, okay, how to learn PAWA. And that for Hugging Face, we use Anthros API, but you can go also to our GitHub and just search IndabaX SLM, small language models. And once you go there to IndabaX SLM, you'll find it notebook, which that notebook learn PAWA open models. So let me go there. So if you go to IndabaX, right, and then you see this notebook. So once you learn this notebook, you open it, you'll see how to learn PAWA open model. So you guys, let me show you Colab PAWA SLM. Yeah. So this is PAWA SLM. I ran it before, just for the sake of this presentation, and I show step-by-steps from loading the models. So this is how to load the models from Hugging Face API, just called transformer and torch. And then I use, I captured just the information about the environment, show the memory before I compile it. And then I load the model from Hugging Face, certify LLC / PowerMini alphas. And then I set the maximum sequence range to 2048. This is very enough for most applications. And then I use Hugging Face API now to load the model name. I convert from 32 bits, the model is 32 bits, to bit float 16. So this kind of quantization to make it even smaller. But you can even use different libraries called accelerate or bits and bytes. So that bits and bytes can even quantize far to 2 bits. That's possible. And then device from Colab, you can either choose either T4 or L4. Both they are run just fine. For CPU, you just need very, very small quantized value. But if you keep insisting on bit 12, 16, I'll recommend you guys to choose T4. So T4 is it's free also. So you can just go to Colab and it's free. And then I load tokenizer. So here I load the model, and are you seeing my screen, right?
Yes, Michael, we see it.
Yeah, sure.
Yes. So tokenizer, I load tokenizer, and then I load the model name. I just choose trust remote code. Sometimes trust remote code should be false or true, but rule of thumb, if you don't want your code to break, just set true, because sometimes they don't believe in model outside of US for some reason. This kind of Hugging Face out sometimes works mysterious. So I try to avoid as much as possible. And then I set the padding. When I do training for this PAWA, we set something called end of tokens. So I set the end of token to be true. I apply the chat templates, so I have to change from the base model chat templates to something called ShareGPT, because we want to use ShareGPT chat templates. So I change to ShareGPT chat templates, and so this is just a function to change any user input to ShareGPT formats. And then I call the function to generate response, whereby by default I set 64 if it's not set as arguments, and then the message it will be the message which will be converted with a chat template as a tokenizer. And then because the ShareGPT, the role user content message, so this will be a message of the user, and then I apply to tokenizer. Because you have to tokenize first, and then I apply, we call it KV-cache. We don't want to store much of KV-cache before, so this is kind of, you manipulate the KV-cache, I don't have time to explain much about actual KV and Q works, and just for now, just use it. And then I set touch guard, so I don't have to make any gradients. So this is also reduce memory as much as possible, because here the point is to minimize the memory. So by default, touch, if you call it a touch application, it comes with a gradient, so the gradient increase another memory. So I set the touch is equal to no gradient, so I don't want to store any gradients. And then I set some other input arguments, which is maximum token. For that case is for 2048. Do something true, yes, I just need random answers, kind of. The temperature I set 0.2. I'll recommend, guys, if you want to have very, very replicable results, just set between 0.1 and 0.2. But if you want a kind of different kind of innovation or different results, kind of, you can just even set high temperature, but it's not reliable. I don't recommend that. Top P's are just top probabilities of top P. Okay, in terms of probability, when it's output from Softmax, how much you can get from the how many you can take those tokens and want to do sampling, right? And then per tokens is already set to per token, and then end of words, and then use cache. True, I want to store some cache. So next time with a query, it will refer to the previous conversation. And then I ask a tokenizer to convert back to the response, and then I send response. So I asked a very basic question, baba yangu ni shujaa na anaishi Marekani. That was very basic question. And then I use that PAWA model, which is 2 billion parameters, to make a translate to English from Swahili, the following sentence, and then I feed the following sentence. Baba yangu ni shujaa na anaishi Marekani. And then I don't know what the meaning, but baba yangu ni shujaa na anaishi Marekani. Anyway, I know, but for this case, it's I make application, which is translate application, and it's just this is just one of application which you can make, which is translation application. I fed the message, which is babangu ni shujaa anaishi Marekani. I set the maximum token 128. Remember, if you don't set it, it will be default 64. So you have to know, okay, what's the use case? You go sentence level translation or whatever, the paragraph level translation. And then I print the results. And then I print the memory footprints again. And this is the results now. So first, it loads the memory. It shows the GPU, which is use it, which is L4. For this case, you can use T4, but I just use L4 because I'm using paid version of Google Colabs. But T4 is free; anyone can use it. The maximum memory allocated from L4 is 22 GB. Reserves inference before inference it was 0.0, and then it load the model, and then it loads it prints the query, which is babangu ni shujaa, and then it generates the response. So the response, because this is how we made it, to make chat templates to show the user start and assistance. It say translate to English from Swahili the following word: baba yangu ni shujaa na anaishi Marekani. And this is the output: my father is a hero and lives in America. I don't know if it's true or not, but this is how it works. So you see the peak memory, if we load that gamma, that PAWA actually. So the PAWA actually, this PAWA 2 billion is based on gamma textures. So if I change it using the term, is fine. So the peak memory we achieve is 5.4, which that means this model can even learn on phone, most phone nowadays, right? So, and this is not even optimized too much to be applicable on phone, but yeah, as you can see, it runs on phone just fine. So based on 22 GB I have it, the total memory used it almost 24% of T4 of L4. That means you can host this model on your computer on consumer GPUs, and you can run applications, save millions of Tanzania there, just fine. You don't need to pay OpenAI. You can even host in your system and you can run just fine. Yeah, so let's get back to the presentation. So this was just showing how to use PAWA to do some different application, and that application I show you, and even the memory it consumes. So in a nutshell, so why we need SLM? So SLM makes AI accessible. Everyone can use now AI because can own AI because of SLM. So the SLM actually lower the barrier of AI adaptation. So you don't have excuse now anymore of say, okay, we don't have GPU, so we can learn any AI. You can learn AI and AI without even GPU. Provided you have a computer, you can do tricks and tricks, and you can able to learn open AI on your device. Actually, I'm learning PAWA. We call it Braze PAWA from Certify. Actually, I learn on my MacBook. So normally I don't pay for OpenAI, and I'm learning PAWA just fine for most application. And the good thing or the love about it, I use the same PAWA to develop a data set. So this is a platform where we generate our data set. 1 minute. Yeah, we call data curator, and probably we'll ask a community actually to if you want to help us to contribute to data, will be much appreciated. We can give you access in terms of username and password, so we can able to track what you have been submitted. So this is just example like how the platform will work. So you see, we're creating different type of data set, like many data set, we create different type of data set. So one data set is like self-instructed. If you see, so once you have prompts, you can feed your prompts, and then you can feed your input if your prompts need some input, like a markdown of your content, and then you can feed output, and then you can submit. So once you submit, we promise this data, all of this data set which people submit will be open source. So anyone, they can use this data to make their own models. This happens a lot in Europe. For those who were in Europe, we sometimes collect data for free, but only in Africa, if you ask people to contribute the data, they want money. But in other places, contribution come from people and it's free, because once we have data set actually for fine tuning, for example, this is when we can own our own AI, and especially if you are data set for Swahili or your local language, we'll much appreciate that. So this is one of the, for example, submitted data set from people from our company. Let's say this was a query, kifungu gani cha Bible kinasema kufa ni faida kuishi ni Kristo. So this data set, so once you have very good prompts, so like this is a good prompt, people can use it to prompt the AI, and then the output is like this, andiko unalotafuta linapatikana katika Wafilipi. So this makes a lot of change. So once we feed this back to our PAWA again, the PAWA will have very good understanding of the data and cultural essence of the place. So from Certify, even though we are working actually with another company to make a data, also we have a data team where we also provide the data, we create the data, we created data from images, videos, audios, 10 of them anyway. Yeah, so once you're done with that, you just submitted it, and then we can compile and push it to our hub to make it open source. So we have plenty of data sets, actually plenty of data sets, and yeah. So let's get back to SLM. So idea is to democratize the AI. So every company should own their own AI, every company should own their data, and that makes better. So interested candidate who want to contribute the data can create them account, or can create them account, and then they can start contributing the data. And then the perfect use case is real-time application. So we expect SLM to be used for real-time application, most of mobile edge device and computing. And issue of privacy is more important, and resource constraint necessary to use as the small models. So what's the future? You know, the future is not about competition between SLM and LLMs. The future is hybrid. So we have one client whereby we even fine tuning, and then still the user in that space, they want some reasoning question and answer, and PAWA doesn't support reasoning for now. Later maybe, later definitely, yeah. So we have to create something called Looter. So Looters is also, we fine tuning very small models, very fast models, to distinguish or to choose when to use GPT and when to use OpenAI. When to use PAWA and when to use OpenAI. So we coexist between PAWA and GPT. For those who love GPT, it's very easy. And then when user prompt a question, and then Router will decide, okay, this time it will go to PAWA, this time it will go to GPT. The objective, main objective, to minimize the cost and also to maximize the response, right? So router will try to maximize and minimize, and then there's a feedback loop, goes to router again and try to optimize again. Yes, because we know different models, especially SLM and LLM, have different needs and capability. So we wanted to make them, okay, supplement each other. And actually the client has money, so for them it's not a problem. Yeah, so this is a kind of PAWA interface. Any one of you can go to www.pawa and hyperpenai.com, and you can start chatting with it. And it's SLM for now, and we're expecting to run new trainings to Power Blaze, which would be great and very good. Yeah, apart from that, thank you, Ronnie, and thank the team and everyone for listening. I'm expecting a lot of questions, and I'm here to answer them. Thank you.
Wow. Thank you so much, Dr. Mollel. That was an amazing presentation. I love the technical detail there and all the different features that we all learned, and also your tips on best practices, right? And pushing SLM use. Yeah. Fantastic. Thank you so much. We have questions now from Udon. Yeah, please go ahead, Caribou. From Udon Hub.
Okay, thank you very much. Hello, can you hear me?
Yes, we
can hear you.
Okay, thank you very much. I have two questions here. The first question is, you have told us the technique on how to create your own SLM. There's a lot of technique there, pruning, like quantization and so forth. So what are the factors which can force me to choose a specific technique which will be more based on my problem domain? What are the factors which can hinder me to choose the best technique in order to get the best results based on my own domain? What technique, what factor can force me? And and the second question, in the last chat there, I saw you put two SLMs there. You put the PAWA and you put GPT. Why did you decide to put both of them? And what's the real meaning of putting that GPT?
Yeah. Is that all?
Yeah, that's all. Thank you.
Yeah. First of all, thank you very much for the questions, and I love the questions. And to be honest, I must speak this kind of question very intuitively and try to understand the case. So there's no one versus all, right? So assume you want to adopt to agriculture, right? And for some reason, your big LLM is very good in agriculture. It's very good in agriculture, very good in agriculture, right? But it still is big model, right? Do I need to prune it? Yes, might be true. But once you prune it, the problem will come. Once you prune it doesn't work out of box. Once you prune it, you need also to fine tune it. Do I have a data for fine tune it? You have to answer either yes or no. So once if no, and you already know the big model is very good in agriculture, pruning is not good, right? So what if I have very good model in agriculture, right? And I don't have the data to fine tune it. So the best option is to quantize, because once I quantize, I don't need to fine tune most of the time. I can fine tune, but not necessarily. You can lose performance, but not that margin. Normally, you must have something we call benchmark data, whereby every procedure you do, you have to measure against your benchmark. So you measure before you do these techniques or these methods, and then you measure, okay, how good my models with this data, and if it's not good, when is the LLM is good, and once you prune it or you quantize it, you measure again. Okay, what if I quantize and what's the performance? So if it reduced drastically, like let's say from 90% to 10%, definitely we want also again to fine tune it. you come back to square one, right? And this is when now, so for that reason, you already know, okay, once I quantize it, it's very good in specific questions, right? But in specific question is not good. You can, even that benchmark, you can categorize maybe easy, difficult, or hard, or maybe moderate, right? And then this is when the last procedure you see, I show you like how they can coexist between big and small terms. So you already know when it's easy answers, whereby quantize work just fine, right? The quantization will just answer the question and it will be perfect. But if it's not fine, it will be a difficult question or different prompt you feed. This is when you go to GPT. So this we call router. So router will choose between PAWA, which will answer the basic question or model or easy question and the moderate question. And when it's difficult question, the router will choose to go for GPT to do a response. So these techniques, you must have the form flow, and then you feed the gaps like, do I have this? If I not have this, what would be other options? So there's no like one versus all. You need to do a planning and strategy of how you optimize. But remember, your objective function is to maximize as much as possible response from those techniques. I don't know if I answer both of your questions.
So there you mean that if the question of the user is out of content, probably the router will route that input to GPT, right?
Yes.
So, and the GPT will give the general concept, and that is the main objective of that system?
No, so the GPT will give you the actual answer to the question. And the user, because the point of answering the question is the user to be satisfied, right? So the user will be satisfied with that, and that's all. And then you take the feedback again from the response from GPT. Next time, you go and fine tuning to your PAWA, right? So you add the knowledge which will distill from the GPT. So this is when distillation comes. So it's very complex to create a system whereby it's not complex, but this is how actually you're supposed to do. So you started with complement between GPT and your small models, and then eventually, as user interact with it, it will starting goes back to your small models. So at first, most of the time it will go back to GPT response, and then the response and question you feed back to your PAWA, and then PAWA already has that knowledge. Next time, if user asks that question, also PAWA will have the knowledge and will answer like a GPT. So it's a iterative loop. And that's a good practice. But so in router, you can do router in two ways. So router might be SLM or router might be threshold based. So threshold based, you just sampling, let's say 90% of queries when or 99% of the query when I initially start my system to go for GPT, and 1% go to PAWA, right? So only 1% will go to PAWA. That is a heuristic approach, and then 99% will be go to GPT. And as much as times goes, the threshold will go down. So from 99%, it might become to 98%, 97%, until you reach 0%. So at that time, PAWA will have all the knowledge which GPT have. I don't know if you get my point.
Yes. Thank you very much.
Yes.
Nice. Okay. Any other questions online? Kosauti? We actually have about 10 more minutes before Freddy's ready for the next presentation.
Yes.
So maybe
that's why I'm
look at the chat.
Let me look to the chat now.
Yeah. Starting with Bonge Kile. Can you see that one?
1 minute. I don't know. Can you share link to SLM example now?
From about 1209. About
12?
if you want to build agent for conflict alerts in Southern Africa region. Is SLM recommendable with sources from socials? Do you see that one?
Is 10, what time is that? I don't
For us, it's 12:09.
Okay, if I want to build agent for conflict alert in Southern Africa region, is SLM recommended for source? Yeah, I mean, it's recommended. But as said earlier, you must have the benchmark to evaluate your system first, and then you can say, okay, I can complement each other between any big models, which is very good on that out of box. If there's no any out of box which works on your recommended system, you need now to create your own data. And once you have created your own data, which might be human in the loop or any AI with a human in the loop, this is when you go back again to fine-tuning either big models, small models. And once you fine-tune small model to based on that data, it will work just perfect as fine. So SLM is working just fine, but you must have the benchmark. Most of the time we don't have the benchmark and we just want to deploy as it is, but that's not the good practice. Yeah, so definitely, yes, it's recommended, but it depends. It depends. Another question, great and inspiring talk. Thank you, Dr. Dina. Thank you very much. I was your student, so so this is also inspiring from you. Thank you. Some of your presentation is more important. Thank you, Ruvenga. To use SLM in my project or research, should I use LLM and then customize it, or there are some open source models? So I don't know your Makanta, your project, but unless otherwise I know your project and try to find an open source availables, and I don't know your project is about. So it can be true or false, or can use both of them. I don't know. That's the thing I can tell for now, unless I know the more detail about it. Insightful presentation. Thank you, organizer. Thank you, Bongekile. Thank you, Dr. Mara, for a great representation. Thank you, Liston. Hello, Dr. Mori. My name is Piana Mwasekwa. Piana, I know you. Presentation, you mentioned about few boards that support SLM, and also that's other like Raspberry Pi. Just yes, a question: what is your experience with the performance gap between training, validation metric, and actual device performance when you apply this optimization technique? How do you account for the reward deployment? Yeah, so Ipiana, we have very good application we submitted Nature recently, and we're using Raspberry Pi, and they were no different with using real world deployment, because it's actually it's a real deployment of our SLM to Raspberry Pi. It works just fine. The issue is don't optimize it when it's not necessary. Sometimes, for example, Raspberry Pi support up to I think Raspberry Pi 4 plus support 8+ GB, right? So, and as you can see, if you just want to question and answer application, and the question and answer application maximum lands up to 5 GB. So why do you need actual another optimization? It can just run fine and with high efficiency. So actually optimize when it's necessary. If it's not necessary, don't optimize. So if you run on very like small devices, like I think Nano is also support higher VRAMs, like Arduino, for example, right? This is when you need very small models and very high optimization. Yes, but remember, most of us, for example, they said, okay, use Olama or NSLI. Now they put it. They can run on your devices, but remember, if the data set for training, right, is a distribution for training, or your data set is out of distribution for the original model before even quantizing, it won't be good, unless otherwise you use lag to supplement. Yeah, so when you quantize, for example, it doesn't lose instruction most of the time following, but sometimes it loses the knowledge. So if you don't have knowledge on first place, even if you run quantization, it doesn't work, right? So this is when you do best practice by just trying to, as much as possible, to evaluate or benchmark before you deploy any of your system. How do you compare PowerSLM to Lelapa and Kumba? So Dr. Dina, Lelapa is very small models. I think is 400 million parameters, and Power. So to be honest, Power is very efficient compared to Lelapa. But anyway, to be very unfair, if you compare to Nkumba, because Nkumba is very small model, is in category can call it tiny LLMs. So and Power is pure SLMs. So it will be unfair for Power to compare to Nkumba, but Nkumba is not even close to Power, but yeah, because of parameter. It's like comparing Power to GPT. GPT is very big model, it's 1 terabyte parameters, and Power is 2 billion parameter, is almost 1,000 times. So once you do comparison, it will not be fair, because one is so big, like it's like David and Goliath. Yeah, sometimes happens, but in rare cases. So that's why you don't even compare to Nkumba, because Nkumba is tiny LLMs, and it won't be fair to do comparison with them. Yeah, but yeah, Nkumba can't match Power, so Power is very powerful compared to Nkumba. And for those of you who don't know Power stands for Pan-Africa Wide Alignment Language Model. So it's not like it's come to a coincidence, Power's energy, but
it's a good coincidence though, right?
Yeah, it's coincidence. Yeah. Yes.
Nice. Any other questions for Dr. Mollel? Sorry. If no more, actually, I can ask a few. So since I'm a learner of Swahili language, I'm curious: are there any? Is any easier or more difficult to learn the embeddings or to train using Swahili? Specific features of the language that make it that process different somehow, or maybe even other Bantu languages?
Yeah. So as a Bantu language, not much, but Swahili is very funny. It's not like as straight as English languages or Germanic languages. Swahili sometimes what is written is not the meaning sometimes. Right?
Yeah, I've realized that.
Yeah. So sometimes, for especially for embedding, we tried embedding before, and I can say we've embeddings for Swahili, and then we realize most of our data set when we're doing embedding, they come from translation, and then we realize, okay, it's wrong. It is wrong. It works, but it's not perfect. So that's why now we were thinking of using the actual, since we got a data set actually for Q&As from people and from us generating from Power, we can use Q&A to make initial embeddings where we try to perfect embeddings. So that will be our next project. We haven't started yet for this project, but we got a clear roadmap of working with Swahili embeddings.
You mean Q&A?
Yes.
Pairings.
Because normally when you're doing embeddings, the best in embeddings we use positive, right? Hard negative or hard positive, or hard negative and the questions. So the problem is when you get hard negatives, they look similar to the answer, but they're not answers. So you have a question, you have answers, and you have answer which is very look similar to the answer, but it's not answer. To generate that kind of data set is very difficult, actually. So there's another option for training embeddings whereby you can have only anchor and answers. We call anchors. So that will be our roadmap, because we don't have budget to create actual answers which look similar to answer but it's not answer. That is very difficult. Yeah.
Okay. Yeah. Ambiguous maybe in some way.
Yeah, but we got this last week. I had a meeting with people from Google actually, and we were thinking, okay, what if we can use small models to generate answers and big models for Power Big Model to generate answers? So definitely, the small model will have quite different from answer to the actual answers. But sometime if you ask Mama Samia ni nani, it will say the same thing. The president of Tanzania is a small or big. And this will create ambiguity when you do embeddings.
Okay, I see.
Yeah, so we realize, okay, in the meeting we are so happy, like, okay, this is direction. But when we do experiment actually to create this kind of data set, we realize this is the problem.
So
yeah.
It's in the details, right? Always, as always, the nuances.
Yes. Yeah. So yeah, but who knows? I mean, if it's open source, so anyone can contribute the data. I mean, if from Data Safari or Tanzania AI community, they can make this as a pool, and people can contribute the data, because how many people are we in Tanzania? Maybe 6 million people, and everyone just get one data. That means 6 million laws, and it's the most enough to any AI system in this world.
Yeah, that is a good idea, actually. Someone just needs to kind of take it on and take the initiative.
Yes.
Okay, wow. Which is the beauty of open source, right?
Yeah, to be open source, you know, this is the tool which we need it. Most of us we use embedding from, let's say, OpenAI, which is not sometimes reflect the actual output. For small application, like if you're doing finance, for example, direct finance transaction, it works fine. But if you're generating reports, this is when you realize this is a problem. There's a problem. Believe me, we are trying to do some kind of replicated of deep research for one of the clients where we're using even these big models for their data. We realize this is a problem. When we do embedding, we're extracting something out of context. In Swahili, it doesn't mean the word is there and you do word similarity. Doesn't mean it carries the information you want to extract.
Right.
Yes, unlike English.
Okay, so it's even more context-based.
Context-based.
Okay, wow.
So you need actual very good embedding compared to, let's say, English languages.
Okay, interesting. Well, check Motini first up here. That's cool.
Yeah.
Okay, great. Thank you, Dr. Mollel. If there's no more questions, really thank you for your time so much. That was an amazing presentation. I hope we can share it if that's possible. That'd be great. I think everyone wants to.
I mean, it is there. I think in the maybe the updated one. It is there in the LEPO. IndabaX SLM. It is there. The presentation.
Okay. Okay. Great.
Yeah. So anyone can go there and download it. I mean, this we try to give back to the community, and this is a good service, I think.
I think we're so thankful. Yeah, thank you. And we'll hear more about PAWA in the afternoon from your fellow innocents, right?
Thank you.
Yeah.
Yes.
Okay, thank you so much for your time today and yesterday. And so this is the time to move on to our next presenter, which is Fredy Mgimba. He will talk more about Twiga and introducing the technical aspect of RAG. So Fredy, if you're online, karibu sana.
All right. Thank you. Hello, everyone. Can you guys hear me?
Yep, loud and clear.
Okay, let me share my screen. Okay.
Yeah, we can see it. Parsing.
Okay. Oops. All right. All right. So hello, everyone. My name is Fredy Mgimba, and I am currently working on a project called Twiga, which is an AI-powered chatbot. And today we're going to learn a bit more about RAG and how we're using it on Twiga. And also this introduction will also help us a bit on the challenge, which we're going to learn later today. So think of this as more of like an introduction to better understand how to approach the challenge itself. And yes, the presentation is going to be kind of like a bit straightforward and short. So if you have questions, we can answer them at the end. So it's going to be less technical and kind of like ready for anyone to understand. All right. So here are the things which you're going to go through. First is what is RAG, and then we're going to go to what is parsing, and then we're going to go to how embeddings and retrieval work, then what is an LLM, and then lastly, how it all works together. Now, starting with what is RAG? So RAG stands for Retrieval Augmentation Generation, which basically combines the power of an LLM with search functionalities so that an LLM can have proper information to generate a much smarter answer. So the retrieval part means how we can get most relevant information to provide to the LLM as context. So maybe think of it as like a mini Google search, but then on specific documents. And then the augmented part is basically transforming the input to the model's input, like transforming the message, the model's input or the prompt, so that it can have enough information for the model to have a much better answer to whatever query which a user is going to ask. Then, of course, the generation part is the actual model trying to use all those information to give a much proper response. So think of RAG as an AI that looks that looks things up, kind of like does the Google search and before answering. So, and of course, that's kind of one of the best way to be able to answer any question. So next, we're going to look at parsing. I hope everyone won't mind. We're just going to learn a few of these terminologies, and then at the end of the day, we're going to keep everything together. So we have just checked on what is RAG, and now we're going to go to what is parsing, which is something which is a part of RAG. Now, parsing is the process of getting a more structured information from a document. Now, it's like we're trying to power our mini Google. So basically, when we get information such as a PDF or maybe just a note or any kind of like information, it could be even an image. So basically, we need to have a way to be able to parse that document, kind of like getting organized data from it. And when we have that information, then we're going to store it somewhere, and it's going to be used in our RAG process. So it's going to be used when we actually need the LLM, when we actually need the LLM to have enough context or the proper context to answer a question. Now, you can see there are a few examples, such as extracting questions from an exam paper, so it's kind of like a analogy example, or pulling headings and definitions from a PDF books. So when we're doing the parsing, we need to make sure we're getting most relevant information. So tying this back to Twiga, of course, Twiga is an AI-powered chatbot which enables teachers to be able to better educate their students, and involves features such as, let's say, topic summarization and maybe generating questions, generating exercises. That means we're going to have these textbooks fed up, and we're going to need to get the most relevant information from those so that they can be used when we're actually doing the RAG process. Now, of course, these textbooks could have a lot of information, and some of the information might not be relevant or might not be structured in a proper way. So this is the point where we actually need RAG so that we can be able to extract all this information and then have them ready for our mini Google. Now, when we parse a certain document, those information which we get from it, we usually store them in a database, and usually we use a vector store, because when we get those information, we convert them into vectors, and through that vector store, we'll be able to retrieve them later on. We're gonna get more into this a bit later, but for now, I'm going to introduce something called Llama Parse, which is one of the best ways for someone to easily be able to parse a document, basically to extract this meaningful information from a PDF or any document. So what is Llama Parse? So basically, Llama Parse, it's basically a parser which is built by Llama Index, which is going to help simplify getting this meaningful information from documents, such as PDF, docs, and etc. So it's going to easily understand information such as tables, headings, I don't know, sections, and all those stuff, so that at the end of the day, our context, which we give to the LLM, is going to be as best structured as possible. So unlike when you try to do just plain forward OCR or just a normal PDF extractor, like PDF like content extractor, Llama Parse does a mix of a lot of things, and that's why its output becomes basically the most clean or the most structured data you can get. But of course, other manual options can still be useful and can still be used. So now we go to how embeddings and retrieval work. So up to this moment, we have learned what RAG is in general. Then we learned that we need to get these documents, we need to get the structured information from them. And then when we get the structured information, we store them in something called vectors. And then through those, later on, we're going to retrieve this relevant information so that our RAG pipeline, so our full RAG system can work. Now, let's learn what are these embeddings and how do we actually get back that data when it's needed. So first, we want to start with embeddings. So embeddings is basically how AI understands, gets the meanings of words or chunks of text. And the way AI is going to understand them, it's through converting them to numbers. Now, each sentence, paragraph, or whole document is going to be converted into vectors. And then when we have these vectors, when we store them in our database, later on, when we actually try to retrieve them, we're going to need to do some kind of like a similarity search. So that means we need to get the most relevant information, which the most similar information to be used as context. So when we get these embeddings, the way we store them in a way which is the most similar ones stay close, and the more maybe less similar, they are stored apart. So this means when we need to retrieve information, it's going to be pretty much easy, because all the relevant or all the similar information is going to be it's going to be much closer to each other. So we're easily going to be able to get the most relevant information to feed back to our RAG pipeline. So again, where are these embeddings stored? So we store them in something called like a vector store. So it's basically just it's basically like a database, but then which stores vectors instead of just normal text or other data types. And a few examples such as ChromaDB, Pinecone, and etc. So again, in our pipeline, last week, as we said, we need the retrieval. So the retrieval part is basically we want to get the most relevant chunks or the most relevant information to be used in answering that question. So this is the part whereby we try to get those information so that our main prompt would have everything needed. So basically, until now, how the flow looks like is basically the user asks a question. The question has been turned into vector embeddings, into an embedding, and then the system compares the vectors of the question to see if there are more similar content in our like vector database to be used as context. So at the end of the day, when we get those vectors, we send to the LLM the question plus those relevant information. So if the question asks about maybe where is, let's say, Tanzania located, of course, maybe in our document, we have maybe a list of all the countries in the world. And in that list, we have countries in Africa, right? And then we have Tanzania in there. So at the end of the day, when we get those relevant chunks, we're going to get all those most close related information all together. And then even when we ask a question such as maybe what's the neighboring country to Tanzania, of course, when the context has been retrieved, we're going to get those similar information, since the countries, the way the data is stored is maybe in Africa, here are the countries, in East Africa, here are the countries, then Tanzania is there. The context is easily going to have all those relevant information to easily answer that question. So that's the base of how the embeddings are, how we do retrieval. And now let's go on. So the last part we're going is what is an LLM? Now, we've been able to convert these documents into embeddings. We've been able to store them. We've been able to do some kind of a retrieval. So now we're technically formulating our prompt. And our prompt is going to have the user's question, the similar information, and then where we're sending this question, we're sending it to the LLM. So an LLM, or a large language model, is an AI trained on massive amount of text. So then it can be able to predict the next token, to predict the next words according to a certain number of provided inputs. So through that, it basically understands the pattern of language and can be able to answer almost any question. So basically, it can answer questions such as maybe summarize, translate, write essays, etc. And examples of these are some of the tools which I'm sure most of us use, such as ChatGPT, Gemini, Cloud, DeepSeek, etc. So another quick fact we should know is like LLMs are trained on data, and this data can be up to a specific point of time since when the training started. And then that means the LLM is not going to have, it's not always going to have the most relevant information. So it may try to guess, or sometimes we call this hallucinate, or miss the most relevant information. Now, if you go back to what we've just done, is we have already given it the most up-to-date or the most relevant information. So therefore, the LLM is going to be able to answer much, much better. And this is technically the main reason why we need RAG after all. And also just a few additional points on this. When we do this retrieval and we try to get the relevant information, it doesn't only mean we could get the relevant information from the documents. So this is also a point whereby maybe in like a production ready system, you would get information from your database, your normal database. And then maybe this could be the point which you also get information from the web, or you do some other searches, which is basically, now we said our documents are basically a mini Google. So then you could also include information from outside that. So let's just finish up by keeping everything all together. So we're going back to just looking at the whole flow. So first thing first, the first thing we do is we parse the documents, we get the key information, we store the data into a vector store, which is a special kind of database. User asks a question, we retrieve the most relevant information. The LLM uses all of that to generate an answer to our question. So here's a quick diagram, which is also going to help us understand what we went through. So as you can see, we have kind of like two sides. So the first side is basically the indexing. So basically just another term for what I was talking about, the parsing part, which is we get the PDF gets split into, let's say, text chunks. And basically this part is where we're going to need the llama parse. And then here we're going to need an embedding model. So it is another kind of like it's another model which is going to use to just convert the text into embeddings, which is this vectors. And then we store that information in a vector store. Now we go back to the second side, which a user comes in, ask a question. The question is being sent to the embeddings model, which is going to convert that question into embeddings. And just like information here, the embedding model used here, it's technically going to be the same one which we use here, or maybe a similar one or a compatible one. And then when we get the embeddings for the question, we go and query, we go do a similarity search in the database on our kind of like mini Google. We try to get the most relevant information. Then we get all that information, we send it back to the LLM, then the LLM uses all of the context which we have to generate the answer. So basically, that's the whole structure of RAG, and this is how most of these chatbots or these tools such as ChatGPT, Cloud, and etc. work when you actually try to ask for information, let's say, which are specific or maybe which are like up to date. So this is basically how the flow works. But yet again, this is kind of like a more simplified version. Also, just to go back on Twiga, so of course here we're going to see a few more extra parts to understand how kind of like production ready system works. So the user messages actually comes from WhatsApp. Then WhatsApp goes to Meta API. Meta API calls our backend, which is how we receive the user's query. And from that, of course, we have more things than what we just talked about. So imagine when we have the query and we see that we need to go get information from a certain textbook, maybe a history textbook for Form 3, that's when we do the retrieval part. And we get those relevant information through doing the search using the query as embeddings. And then when we get those information, we call our LLM. So for us here, the LLM is, we inference it from Together AI, which is just an LLM provider. And then from there, we have everything as what we just talked about here. And we get our response and we send it back to Meta API, and Meta API sends it back to the user. So yeah, basically that's all we have on this presentation. Like some few questions, and also we're gonna dig deep into some of these parts when we are doing the challenge introduction. And yes, welcome everyone.
Nice. Thanks, Fredy. I think we'll all have a much better idea of RAG and how it fits in and why it's needed for beyond just LMs. Thank you very much. Udom has a question. Kiribu, for Fredy.
Okay, thank you very much. First of all, congratulations for your wonderful presentation. Mister, I have gained a lot. Thank you. And I have few questions here. The first question is how those embedding of doing query embedding and query generation model, which type of embedding are you using over there? That's the first question.
Mm-hmm.
And another question is, how are you filtering to get those top chunks from vector database to LLM? that the technique that are you filtering in order to get the top K chunks? What technique are you using in order to pass it to LLMs? Yeah. And the last question, what are the difference between fine-tuning of LLM and RAG? What are the difference? And which between those two, which has more use cases? Thank you.
Okay, thank you. Very, very good questions. Very good questions. So, number one, I think you asked about which types of embeddings. So this is basically text embeddings because the example here we're just saying that we're gonna try to convert text information. So we're using text embedding models, and some of these models can be such as the OpenAI text embeddings, other, let me search it up, 002. So basically, it's just an AI model, which all it does is converts the text into these vectors. So that's the types of embeddings we're talking about here. But of course, there are different embeddings compared to different kind of like information you use. So for image, they could be, you could use different embeddings model to be able to basically convert this information into vectors. Second question, I think you asked about how we're doing the filtering in terms of the top K matches. So basically, what happens here is we have our embeddings. We have stored them in our vector database. We have done the similarity checks, like similarity search. And when we get that information, it doesn't always mean the information we get is going to be in the perfect order, right? Or in the perfect like sort, basically. So we can basically do some kind of like algorithm to be able to know which one are the most relevant, and then through that we can provide the most relevant information first to the LLM, or we could even filter out certain information which, of course, they're relevant, maybe not relevant enough in terms of our standard or maybe our threshold, right? So that's what happens here. And so at the end of the day, the LLM is actually going to have, of course, the most relevant information, and not like the relevant information, but then again, it's going to have the most relevant information because we try to make sure we're getting the most similar context sent to the LLM. Am I missing any other question? Or are we all right on that?
Yeah, we are right. But the last question was the difference between fine-tuning and RAG.
Yeah. So fine-tuning, it's basically you're going back to this stage here. So RAG is what you do in, basically, I think you can see my cursor here. So RAG is basically what you do at the points which is before or after sending the information to the LLM. So this is whereby we go get the relevant information, we use different data sources and everything. But then when we talk about fine tuning, is we're actually trying to update the actual LLM. So remember, we say that the LLM is going to be trained up to a certain point of time and through the data which has been provided to it. But sometimes you'd want the actual LLM to get the most up-to-date information, or to maybe fit a specific domain, like let's say to focus on a specific industry, let's say. So that's when we do fine-tuning. So you're actually updating the LLM with kind of like more information or kind of like more knowledge, or sometimes it could be you're even giving it different ways of thinking or solving a problem. So that's what happens in fine-tuning. But then in RAG, we're not touching the LLM, rather than we're touching everything before and after the LLM to make sure the LLM gets the best information it could ever have. Yeah.
Okay, and which has the many use cases between those two.
Okay, so if I would say which one is more common, I would say RAG. And if you'd ask maybe which one is the best or which one's the most common, like the one which you should use, it mostly depends on what your problem is. Now, in some areas, RAG could be a disadvantage because if the LLM really doesn't have a lot of information about your maybe your industry or the specific use case you're using on, that means you'll have to do a lot of heavy work on the RAG side, and that can be expensive over time, right? So imagine instead of always sending, let's say, the how would you say this? Maybe the atlas, maybe the atlas book, or maybe a specific instruction to the LLM when you're doing RAG. Imagine the LLM always has that information and always keeps that information in mind. Like if you have some information which is pretty much constant to your use case, you obviously need to fine tune the LLM to that so that you don't have to do the RAG process all over and all over again, right? So basically you need to know what area do I need to optimize, either the actual LM or the external factors. And in most cases, you are better off using RAG because at the end of the day, it's going to be pretty much less expensive, and you're not tying your LLM to be more specific to one thing. And that means when you do fine-tuning, you might end up being like the LLM is more fine-tuned to a specific thing, and then later on you want to use it to some topic which is slightly less relevant to that, and you still go back to using RAG. So all in all, it's more like trying to see which one is key priority on your side, kind of like in terms of what the LLM knows. And in most cases, you find yourself using RAG because it's going to be significantly cheaper, and yet you be able to easily go to a newer, to a more later LLM, because LLMs have been improved almost every day. Now, if you fine tune one, if a new one comes out, you need to fine tune it again, and that could be thousands or millions of dollars to just fine tune. I hope I've answered that question.
Yes, thank you very much, Miss. Thank you very much.
Okay. Yeah, thanks, Fredy. One in the chat here by Shax. Can you help us to explain about tokenization? I didn't see being explained, please, mister.
Hello?
Yep. Fredy, did you hear that?
Can you come again?
Yeah, just looking at the chat box, there's a question from Shax about tokenization.
Oh, okay.
Can you help us to, yeah, I didn't see, yeah, go ahead.
So basically, what the LLM understands is mostly in terms of tokens. So as we try to define the LLM, it's basically trying to predict the next token. So this is basically how it understands words. So a token can be a part of a word. So maybe if you say I and then like, and so each of those could be a separate token. And the LLM, the way it tries to understand or it trying to generate, it reads one token at a time. So that's how tokens are in terms of the LLM. And you could see that terminology used in most cases in terms of maybe the pricing of the LLM. So to know maybe how are you using it, it's kind of like they look at the input and output tokens, how much are you using them? Because the more tokens you send to the LLM, that means the more information it has to use in order to generate your answer. All right. So again, the tokens are basically how the LLM understands the text, because the LLM does not understand like raw text. So uses tokens, and then that's how it basically communicates in terms of like input data and even how it tries to output the data. Is that definition okay? Or I could maybe dig a bit deep?
Yep, we got an okay in the chat. Thanks.
All right, thank you.
Okay. Anyone else? If not, then I'll ask one for myself. Curious how kind of leaving the technical space and more towards the application, how is it going with the teachers adopting Twiga? I know you guys done some pilot tests in some schools. Is it being well received in general? And are there any challenges of being used at schools in the actual teaching classroom?
So up to the point is the feedback which we get is mostly positive. So
I'm sure, yeah.
And for most of them, it's kind of like you could say an easy way for them to have some of these let's say things like textbooks and other resources in the palm of their hands, because of course they would have a textbook on their phone, but then trying to go through all the information and trying to navigate would be cumbersome. And having a tools like Twiga, it basically helps simplify all that process and keeps everything kind of like easier and faster for them. So you could imagine they're trying to facilitate maybe hundreds of students now, and they want to generate maybe like different variants of maybe questions which are more maybe expert level, more beginner level, and they would have to do a lot of work trying to generate all those stuff. But using a tool like Twiga, they were able to easily kind of like get these types of like information easily generated, and they could easily use it. And same goes in terms of maybe trying to maybe get context, like more information about a topic, or have it more broader or more simplified. So that's how they mostly have utilized Twiga. And from that, we've been learning and trying to improve on those specific areas in terms of the development side.
Nice, nice. But I can imagine it being helping a lot, saving their time finding resources like that.
Yeah.
And then the outputs can be different kinds of outputs, right? Like it can be question answer, it could also be more of a open-ended question. And I think also you can also output like some activity for the students. Is that correct?
Yes, so you could just for example, as I said, you could just say like, get maybe a summary of a certain or an explanation of a certain terminology or topic, but also you'd want to generate questions, and those questions could be just kind of like maybe true or false questions, or maybe want to do like a back and forth conversation with it to basically answer this question and get some feedback on them. So it's not really tied kind of like, here's just a list of questions, that's it. No, it's kind of like more flexible in terms of how you'd want the response to be.
Okay. And each kind of response, does it go through a different kind of flow?
Yes, so we do have tools, so which basically when a user asks a question, the LLM first tries to see what the user is trying to get from it. And when let's say the user is trying to generate an exercise, that means we have a separate logic flow to handle that. And when a user is trying to get a summary, it's a completely separate flow. So we kind of like all these tools which are going to help facilitate different actions. And actually later on, we're actually going to have an update on Twiga to make it more agentic, and maybe that's a conversation for another day. But
your next presentation.
Yeah, it mainly means Twiga is going to be able to just, let's say, give you the summary and then reflect back. So before it even gives you the answer, it tries to reflect back and mainly making it be able to give more, much better responses. And on top of that, you could do more complex things, such as maybe explain this and give some like questions in each and every item or something like that.
Okay.
So it'd be
multiple steps.
Outputs too. Yeah.
Yeah, Fredy, go on.
Yeah, so I'm just saying it's going to have much better outputs and be able to support more features. So I just advise everyone to stay tuned on that. I think by, I don't know, by October or closer to end of the year, we're going to have the agentic version ready. And it's also going to be a really good kind of like learning opportunity for developers, since Twiga is, again, an open source project which anyone can be able to contribute and be able to see the developments and everything we do.
Wow, amazing. Yeah, keep us updated on that.
All right.
Okay, great. Thanks, everyone. Thanks, Fredy, especially, of course. Anything else to show us, or should we break for lunch? And then we'll come back to you after lunch, actually.
Nothing much. I was just showing the Twiga repository.
Someone asked, yeah, the link's in the chat.
Oh, okay. So Twiga's repository on GitHub is right here. So you'll be able to check it out, read the README and everything. And yeah, also, there's also Twiga Warehouse, where you'd see some of these logic which is involved in parsing and the indexing and etc. So you'll be able to learn some information here. I think there's a pull request actually, which is going to be merged soon. It will have a lot more information, and basically you will be able to learn a lot more in terms of how Twiga does its RAG process, how it does the ingestion of these documents. And we're also going to learn a little bit of that on the challenge itself too.
Nice. Huh. Okay, and it's all about getting chunks, right?
Yes.
Okay, we'll learn more about that word. Okay, great. Okay, thanks, Fredy. I think now it's time to break for lunch, and then we'll come back at 2:30 here in Tanzania time, and we'll go into the challenge. Correct?
Okay.
Okay, thanks. Good stuff.
All right. Thank you.
Asante sana.
Thank you very much.
Yep, Freddie's on his way back. He told me so. 2 minutes.
Hello, everyone. Can you guys hear me?
Hey, Fred. Yep, we can. Here, Wasana.
Okay. All right. So we're going to take a look at Twiga challenges. The challenges are based on Twiga. So let me share my screen. Give me a moment.
Yeah,
Can you
thanks.
guys
We see your.
Okay. All right. So as my first presentation, we went through RAG, we talked a bit about Twiga, and the challenges which we're going to see today are mostly going to be related to kind of like the presentation we had and a bit more of some of the stuff we do at Twiga, at the Twiga project. Now, just to have like a quick background for context, and just so I do assume some of you know GitHub. So this is where you probably like store your repositories. And when you go, we have this, we have the Tanzania AI community. And in here, you can see the Twiga repository and also, as I showed before, the Twiga warehouse. So the Twiga warehouse, this is where you're going to see a lot of the stuff which we do in terms of the parsing, the loading of the document, and etc. Also, as I said, there's a huge update which is coming, which is this pull request. I think it's going to be closed soon, and you get more understanding of what we do in that process. And another thing which we're going to look right now is the repository, which is going to contain the code for our challenge. Right, so I'm gonna keep the link in the chat. Where's the chat again? Yes, so anyone can just visit there.
Oh, so we have our own repo. Perfect.
All right, so we're just gonna go through the README for now, and then we're gonna go take a look at the code. So in the repository, which you're going to see is the challenge itself is split into two. So we have the parsing challenge and we have the RAG challenge. So for a beginner, I would advise for you to maybe focus on the parsing challenge. Then if you wanna learn a bit more, you could even like dive a bit deep in the RAG challenge too. So as you can see, when you pull the repo, you're going to see the first folder for the parsing challenge. So most of the things related to it are going to be in here. And then you're going to see this notebook, which is what we're going to go through right now, which is basically going to show us parsing using llama parse. And then later on, you see the repository for the RAG, which we have the notebook for the RAG, which is mainly going to use ChromaDB. But then you can still make a few adjustments, kind of like to improve. So yeah, let's go through the first one. So the parsing challenge, the goal is to parse academic PDFs into structured Markdown for RAG. So you have some PDFs, then you need to use llama parse to kind of like parse them to get this get this markdown content, which is like a structured output, which you're going to be using for RAG. Then the phase 2 is what I said, is the actual RAG process. So we're going to use Python, and you're going to need to do some of these installations. And also, very important, we also have .env. So there are a few environment variables we're going to keep, which is mainly for the API keys to be able to get these models. So we're also going to take a look at that on my machine, because I've already started running the project. Okay, so yeah, so in this challenge, we're going to mainly just test out some of these papers which are here. I hope some of you must have had some of these. So we have the mobile-based deep learning models, ignition awareness, practical machine learning. Yes, so so for the evaluation criteria, I think we're gonna share them much better maybe in the group. But technically, for the parsing, we're just gonna look at how the output, the markdown output is. So we're gonna look at how content accuracy it is, if it's conserve or like preserves a lot of the information from the paper. It can, if it has some of the information such as the tables or figures which are on the paper, citation, and the chunk quality. But we're not going to take too much, we're not going to be too much strict into this. Basically, as long as you have some markdown like content of that, and then we're just going to see how good the chunks are looking. And for the RAG, the repository itself has most of the code to be able to get some of this information. So the moment you run, you are going to see maybe kind of like a JSON, which is going to show maybe how accurate, maybe the number of chunks were used and stuff like that. So we're going to see that when we run the actual program. So yes, then maybe let's take a look at some of the tips for success. So you need to focus on academic structure preservation. So that means when you are kind of like guiding your parsing, you should really try to guide it to make sure it's good at getting this information from these papers, since when you're parsing, usually it really depends on what kind of like document you have, and it's going to see, you need to make it be good at that particular type of document. Then the rest are, of course, like trying different prompt approach, validating the outputs. If it's good or bad, then you're trying to adjust it. And then, of course, optimizing it for the actual RAG part. So if you're also doing the RAG part, so it's technically you're going to make sure the parsing is fine, and then you're going to see how your RAG is actually utilizing the parse content. So for now, we can just go forward and see how it is. Can you guys see what I'm sharing?
Yep. Strategy 1, direct lemma parse.
Okay. On the we also have we have the general README. That's the one which we're going through, but we also have the README for the lemma, for the parsing itself. So maybe we can take a quick look onto this one. So again, the notebook itself is in that file. And another quick thing to see, there are a few tips kind of like which could help you. So of course the prompt, and then there are a few parameters which you can try to adjust. So in the actual code, you're going to see a lot of this kind of like highlighted. So it's going to be kind of like a little bit easier to follow through. And again, we also say, before going to the second kind of like phrase, what are the things which you must make sure your kind of like your output for the phase 1 has. So of course, all the major sections, kind of like set in the markdown and etc. So maybe to just jump forward a little bit, after you have done kind of like the parsing, basically the final output we're looking for is something like this. So as you can see here, this is like a markdown version of the paper, of this specific paper, right? So this is what exactly we're talking about when we say we are converting the PDF into kind of like this chunk. So we're converting it into like a more structured format. So as you can see, this is basically the PDF which was fed in, and the kind of like the final output would look something like this, right? And again, LLMs are pretty much good at reading or utilizing Markdown. So since we have kind of like, we're trying to keep it in a Markdown format, that's also kind of like going to help down the line. So again, we have the Markdown generated for all the 3 papers which were sent in over here. And then now we can straightforward go look at the parsing notebook. So actually, let me just clear the output. So another good thing about this one is, but the challenge is everything works the moment you start. So the moment you pull the code, the moment you keep your environment variables, everything should run from start to end, and you should get some kind of a result, because the challenge is not making it work, it's basically improving it, right? So I just create the output, so we can just try to give it a run again. So let's just go through some of the outputs. So we're just doing some installations. Then we've loaded our environment variables. So some of the cells you're going to see, we're getting some kind of an output to just explain what is happening. So up to this point, okay. So here we have our prompt. So this is the prompt which has been used in terms of parsing the document. So as you can see here, we have commented out some of the kind of like tips or like other options which you might try. So something to investigate on is just editing that or trying the other prompts which are also provided here. Then now we're going to try to go through we're trying to go through all the PDFs. So again, if you're running it on your machine, you might want to kind of like edit the path itself. But for me, the repository is here, and the actual papers and data/papers. So this is where all the PDFs are located. Then at the end of the day, we try to go through all the PDFs which are there. Then that's when we actually go to parse the actual PDF. Now over here, you can see this is where we actually call llama parse, which then we have to pass through a few parameters. So what you can do is you can try to adjust this, and also you can try to investigate and maybe try to see what options which are also provided with the llama parse. So we're going to take a look at llama parse in the website when trying to get your API key and maybe the documentation to learn a bit more. And now let's continue going through this. So here's when we initiate the process, and then as you can see again, the actual notebooks, they have pretty good comments in terms of for you to know what exactly is happening. So all this part, we've configured Llama Pulse, the parsing itself, and then now we see how kind of like the outputance of when the actual, like the request to parse that document has been done and everything, and the past content, where have they been saved and stuff like that. And then again, we have some code which is basically to do some kind of analysis to just help you understand what exactly has happened. And as you can see over here, we see this is basically the analysis for parsing this document. We can see the length, the actual content, the number of lines. We can see the sections, because for these kind of like research papers, we know the content has been kept in kind of like sections, right? So that's why our strategy is more like trying to get these sections and then have them properly structured. That's why we also try to print and see how those sections, how many or which of those sections were found. Then we can see figures and etc. And of course, again, as I said, this is basically something which works, gives you an output, but doesn't mean it's going to be the best, because as you can see here, they say tables mentioned is 256, but actually, I don't really think there are 256 tables in the actual PDF. So there are very few kind of like small areas which have leaving gap for someone to just improve on or just make it better. And yet again, you can just run it from start to end and then have some kind of an output. So yeah, so basically from now we've been able to generate all of these markdowns. Oh, oops, I think it could have been much better if I deleted them, so then you see them being generated. Let me just do that quick. So we just run it again. But as we wait for it to run and get the papers, kind of like the markdown files generated, are there any questions or anything up to this moment? You can see them being generated here. Okay, I think the last one has been generated. Yeah. So as you can see, we have gotten the actual markdowns for each of the PDFs which we provided. And basically, in terms of the phase one of the challenge, that is it. So all you have to is just get in, first thing first, try to give it a run and see how these outputs are going to be generated. So when you pull the repo, of course, you're not going to see the markdown files. Then after the initial run, you're going to be able to see them. Now, after that, maybe initial process, then we can just go and have a quick look on the RAG notebook, and then also it might be a really good thing for all of us to try to do this all together. So after we go through the RAG notebook, after explain all of it, maybe we can even have maybe one or two of you guys who could try to follow along, because we're gonna start again from the process of getting those API keys and etc., and see if someone has been able to at least get a result from start to end. So now we're gonna have a quick look on the actual RAG challenge. So as you can see here, I have the RAG challenge notebook, and of course it also has its own README to basically understand what exactly is happening and kind of like the key things which are needed. For example, the env variables which are needed, and also how exactly it works, right? So it's going to be nice for us to just go through its notebook too, just looking at the outputs and trying to understand how it generally works. So as you can see here, we load the document and we do the chunking for embedding generation. So basically, we generate the vector embeddings, then we store them in the our vector DB, the vector storage. And then we do the similarity search, and then we at the end of the day we get the answer from the LLM. And then over here there are quick there are quick kind of like ideas in terms of how you could try to improve. So maybe just a quick edit of just changing the embedding model. It could be something which makes everything work much better or something like that. Also maybe editing the prompts or trying to change the parameters, which could probably help you get kind of like much better results, right? So let's just go through some of the outputs. So it's just installation of the packages, and then we see we have some configurations. So we might find some things to adjust over here. Kind of like we see the input directory and output, so this can remain the same. We see the chunk size, the chunk overlap. So these are all kind of like variables which you could adjust. The chunk size basically, whenever we're trying to retrieve the information, they all come in like groups. So you can define maybe how big that group should be. Maybe that could be the goal of you getting better results. And also chunk overlap is kind of like the first group could have maybe content A, the second group content B, but then again, you need to have some kind of like an overlap between them. So it's kind of like the same information in both of those groups. So here's where you kind of like adjust that. So which is going to help you kind of like get more information when you are retrieving those chunks. And of course, the most important thing, like the embedding model, so you can be able to also change this. And also the other parameters like the provider, LLM, temperature, max tokens, etc. So then as said, like we have a lot of kind of like comments which are going to help you know where exactly you are. So there you can see like it says the provider, the model you've configured, the embeddings, and the chunk size, etc. All right. So yeah, then we have kind of like the functions which have been used to kind of like do all the processing, kind of like getting the documents, storing them in the vector DB, and to getting them ready to be used. Right, so here we're just loading them and processing them, and then we're going to store them in our database, in our vector database. Then, of course, we do get some of these comments, kind of like showing what exactly is happening. Please ignore some of these errors because of my IDE kind of like interactions. So, but then all the code stuff is going to run. But if you have any issues, we're going to take a look at that all together. So as you can see here, we have been able to get the markdowns, we've processed them, and then we have saved them in the database. Then we have a place where we try to actually generate the answers. Then we have our system prompt, which is defined here. So this is one of the things which you could adjust. Then here's how we try to kind of like navigate it to, let's say, use the specific context. So it's also part of the prompt which you can also adjust. And then we have the actual pipeline, which is kind of like step by step in like initializing all the functions which we just went through. And at the end of the day, again, we also get some printouts, which basically are going to say what exactly is happening. Then at the end of the day, we also get some tests. So as you can see here, we have some few test questions. So if you just want to give a quick run, you can just run everything, then come back, edit these questions, then just run from this cell going down to just see how like our current RAG pipeline, what kind of results are we getting? And then from there, you can then see, oh, it's not doing good at this specific question, or it's not doing good at maybe trying to reference information from tables or something like that, right? So you are free to just like play around with different questions just to see how exactly it works. And then again, at the end of the day, we get good printout showing what was asked, kind of like the context which was provided, kind of the number of chunks and everything, how long it took. And we have this kind of final printouts, which can help you understand what exactly happened. According to the performance and stuff like that, we wouldn't really take a look at that much, but you can also get to see maybe specific, when you change something, maybe the retrieval took a long time or the generation took a long time, you can be able to see all of that. Then at the end of the day, we also get the configuration of the results printed in a file. So we also take a look at that. So which is basically this file, and it shows, for example, here's the test question which was asked, and then here's the answer which was provided. So when you're trying to evaluate or try to see, or how good is this doing, is my RAG pipeline doing, you can be able to just check out this file and understand easily. You can see the sources which it used, you just use this one. So you could ask different questions and see how it's trying to use other papers. So I think in the test questions which were provided, they're all trying to focus one specific paper. And we can see our RAG pipeline actually was able to get the most similar results by focusing on that specific paper and bringing the results which are relevant to that. And another cool thing, we can even see the retrieved chunks. So you can see what information was retrieved and what was used to actually answer that question. So again, when you go adjust things such as maybe the chunk size, right? So you can be able to see the results or maybe the effects of that immediately. And basically that is it. So first thing first, I'd like to just, if you want to try to go through this from start to end with me, you could just get ready, maybe be on your computer, and let's first start going to clone the repository. Then we're going to get the environment variables, and we're going to run this from start to end. And in the meantime, maybe I could welcome if anyone has maybe a question or anything, or you guys can tell me if you guys are ready to go through this with me. Hello, Lonnie, do we have time to maybe go through or maybe do a quick run together, or?
Yeah, Fredy, I think that would be useful.
Okay.
Yeah.
Okay, so
starting with the even the GitHub cloning, right?
Yes. Let's just try to do that from start. Okay, so for me, usually maybe a quick and easy option. If you use GitHub Desktop, might be straightforward. or if you want to use the command line, you can just run git cron then with the URL to get it in your computer, or for a nice and easy one, you could try to just open in GitHub desktop. It's a good option. Oh, I have it here. Let me just delete it on my machine. Or remove it. Wait. All right, so let me just refresh this. So I'm gonna say open GitHub desktop. Then you're gonna get something like this. So you just choose where you want your repository to be. So for me, I just want it to be in this path. Then I just say clone. I hope the PDFs are not too big, but yeah, it's just 30 MBs, I guess. It's gonna be fine. Yeah. So once you have it on your local machine, so maybe you could try to show how it look if you use the command line. So here's like my terminal. So if you're gonna use the command line, you could just go do git pull, then you keep the URL, keep this, then you'll be able to pull it on your machine, right? Okay. And after that, you can go ahead and open this on your editor. So for me, I use Visual Studio Code. So you can just do that, or you could from your terminal, you could do something like code. It could open your IDE if you're using Visual Studio Code, or you could just go file and then open, then you find the directory of where your project is. Good. Now we have two windows here. So this is the one which I just pulled. So this is what you're going to see. You can see immediately there are a few things which are different. So just click this. So you can see the .env is not there. We have the example, env.example. So all you need to do is you just copy and paste it. So you have like a duplicate of it, then you just rename it to .env. Then now we need to get our API keys for whatever LLM provider we're going to use. As of me, the one which I tried using, okay, we can see my env, I guess. Yeah, so I tried to use Gemini. So all you need to do is set the LLM provider to Gemini, the model itself, and other parameters. So basically, yeah, so basically you're gonna have those values in here. So it's the same thing as just commenting out these, right? Just commenting them out. Because you can remove the comments here, and then keeping the values which you're going to use. So for the provider and also the LLM. So for now, we're just going to try to use. Okay, we're going to try to use the ones which I was using. So I can just copy this and have it here, right? Now, for the API keys. So first thing first, for the first challenge, the environment variables, environment variable which you mostly need is the llama parse. So we have the link here, helps kind of work. Let me open it, yeah. So yeah, I'm gonna keep this on chat too. Oh, sorry. Yeah, you can use the second one. Yeah, so you can visit that, and after you've logged in, I think they'll ask you to write like a project name, and after that, you want to go to bottom left, the API keys. Then you're going to create your API key and copy it. So you can just do now. All right, so when you create your API key, you can copy it, and you can see it starts with the LLX. So this is the one we use for the llama parse. So you can just change this here like that. And for the LLM, the one which you have tried, and maybe you should also, you guys should also try. I think Gemini, they do provide a lot of kind of like tokens in terms of like a free account. So do I have a link here?
Hey, Fredy.
Yes.
Yep. Is there one of those that you recommend over others, or?
So I recommend to use Google Gemini API key, but then you can still use OpenAI. So I think maybe OpenAI could also be a very good option. And also I have configured for Anthropic. So if you want to use like cloud models, so you could try that out too.
Okay. Okay, thanks.
So when you do get here, then you can also create your API key. So just select a project, or they'll ask you to create a project. Then you'll be able to generate your API key. Then you can copy it, and this is the one which you're going to use here, the Gemini API key, right? Now, once you have all of this set up, same as what I have, I hope some of you guys are maybe trying to follow through. Then we can be able to go open our notebooks. So you can see in the RAG, we have the README, and then we have its notebook, and parsing saying that in data, we only have the papers here. Great. So then you can try to run, and then you're going to be asked to select your Python environment. So if you have Python configured, you should be able to see some options. And depending on your machine, you need to install Python. So you're going to, for example, if you're using a MacBook, you're going to use Homebrew maybe to install. Or you guys can ask me if you need help on also configuring that. So I'm just going to select a version. I think that I think the one I used was, let's try. Change. All right. So I just selected the Python and the Python version which I'm using, and of course I selected the run all. We can see I've already started installing the dependencies. I think someone gave a comment where in installing dependencies too. Oh, sorry, someone said I go fast. I'm sorry, guys. So, if you guys are in a certain, if you're stuck in a certain stage or you're somewhere, you can just let me know. So if I can go back. But until now, what we have done is we have cloned the repository. That was going to be the first link which I sent in the group, in the chat. And secondly, we have went to get our Llama Index API key. And then third is we have gotten our Google Gemini API key. I think I haven't sent a link for this. Yeah. And third is we've gotten our API key from Google. And after that, we've been able to set those environment variables in our .env, which at first we just duplicated the example env. Or what you can do is you can just copy everything, then create a new file and call it .env. Then you can have the content paste there. Then you're going to replace your Llama index, your Gemini API key if you're using Gemini, and also the provider and the model, etc. So these are kind of like the configurations which I'm using right now. So I think to start with, you could try keeping the exact same configuration just to get it running for the first time. All right, I'm gonna wait a bit, so if just in case someone is a bit behind, and yeah, so if anyone is stuck, you can just let me know. I'm just gonna wait for a minute or so, then we can continue. All right, so I'm gonna go ahead. So as you can see, after I've tried to run all the cells on the parsing notebook, I think we haven't gotten our markdown files generated. So I think we should see maybe there's an error or something. Parsing. Rising. So we're not having an error. So I guess could be the directories. So we need to have this input papers. Let me just have it created. Yes. And also we do have vector store, which is also inside data. Okay, so let's just try to run again. So the only additional thing which I just did is I created the input vector, the input papers and the vector store directories inside data. So I think that was the issue. So we could try to run it again and see if we're gonna have something generated. And so we could also restart, try to run all again. So it is trying to process the papers. Oh, I just saw so I just saw the mistake which was happening. So one thing we forgot to update is the path of where the actual maybe the papers are, and also where the output should go. So as I said, you need to adjust this. So for me over here now, it's going to be so yeah, I think that was something which you're supposed to change. So again, for everyone else, you're gonna need to change from the beginning, and one of the ways you could be able to know your exact path is, for example, you can go to this data, and then you can say copy path. And then when you do, that's when you're gonna get your exact path, which you need to edit to specify where the papers are and also where the input is going to be. So I've edited that. Let me see if there's other areas which could need that. Okay, I think that's on the output. So let me just run again. So I do see a question which says, how does the temperature setting in LLM affect accuracy? So the higher the temperature, the more kind of like randomness it's going to have. So the lower the temperature, the more I could say maybe predictable it's going to be, or it's also maybe going to follow your instruction a bit better. So for us, we kept it at 0.2. So you can just use 0.2, 0.1. I think that can be good because you're making it as low as possible away from 1. And then it's going to be more like kind of it's going to have less chances of hallucinating. So yes, you can explore on the value itself and see how exactly it affects the output. Okay. So yeah, okay. So after updated, after I fixed the directory issue, we can see our markdown files have been generated. All right, so they're right here. And then what is next is to actually run our RAG notebook. So then again, as I said, the moment you pull the repo, you have configured the environment variables, it should be able to run. So I'm gonna add on the chat a few of the things which we did. So we created the directory, the vector store directory, and the input papers directories. Folders in data. And also we updated the path for the data, which is for the input papers and the actual papers. So I think I'm gonna do a commit, or someone can just do a commit trying to fix that issue, the directory. So I think the problem over there is just updating the git ignore. So maybe to include the actual folder, maybe just not to include the content inside. Same thing for the input papers. So you could have the folder is not the folder and not the content, because everyone is going to have their own generated markdown files, but this directory maybe should be there. Okay. I think this is still installing, so I could check on the chat. Oh, so someone is asking why I opted for the notebooks and not just Python script to do the parsing. So basically, I just wanted something which you could easily be able to, anyone could just follow through and be able to just do a few tweaks and get a good looking output for that. So I thought the notebook could be maybe an easy way for someone to just understand what exactly is going on. But yeah, yet again, you could use just a script to be able to do this. And also, even for Twiga, when you go to the Twiga warehouse repository, we are using scripts to do this process. So for the sake of the challenge, or for the sake of trying to make it easily to follow through, that's why I use the notebooks. So I think it's continuing to install the dependencies, and we're gonna see it. We're gonna see it complete too. You can see there's some files which have been generated for the database, for the vector database. The vectors have been created. So again, also the reason for using ChromaDB is just for simplicity, but you could use any other vector store database. And again, for this challenge, I just kept ChromaDB so anyone can just easily get started with. Since if you try to use something like Pinecone and etc., you need to go create an account on their site, you get the environment variables, so it will just be more friction. But for the sake of just testing out, we just use ChromaDB. But again, as someone who's doing the challenge, I I advise you to just use ChromaDB, but again, you could use any other type of vector database. Yes, let me also share the link of Twiga Warehouse. Again, for Twiga Warehouse, I would suggest you check on this pull request. There's a lot of new changes we did, and this is where you're going to see the cool stuff. So let me just send the link with that PR. But also you can just visit it directly here. You can see the LM was initiated, and we had our test questions asked, and we also got our answers. So basically, this guide is to show you how you can just have the you can do parsing on a document using llama parse, and also have a very simple RAG pipeline, and how it can have these outputs and trying to get you to understand what's going on. And the exact challenge is to get everyone to try to see where can they make improvements in this. So in the parsing area, where can you make improvement, and also the RAG side. But for parsing, I suggest to stick to using the llama parse. And also, maybe most importantly, the output should be Markdown. The structured output should be in Markdown. So since when we're trying to judge that, we're going to look at the actual Markdown which were generated. And also for RAG, you can change things around, but I do suggest to stick to using ChromaDB. But then that's not that's completely optional. And at the end of the day, we're expecting when we run your code, we're going to see something which is running, and we're going to look at the outputs and try to see how more accurate they are compared to the outputs which you got from other people submitted. So basically how it's going to work is we have kind of like a list of questions which we're going to ask. So we are all using the same papers or the same PDFs. And when we are trying to judge, is we're going to ask specific questions. Then we're going to see whose submission were able to answer those questions most accurately, and also try to take a look at the code and the approach of how that person went through doing it. So yeah, any questions? So what are the side effects of using light LLM frameworks for easy shifting of the LLM to use, like in relation to LangChain? So you can use any other framework, but again, the reason for LangChain is it has a lot of things which are provided to make the whole process easy. So in terms of how you are calling the LLM, for example, even the way we are able to support the multiple providers is because we're using LangChain. So I think also, just as an advice, you can just stick to using LangChain in terms of how are you going to call the LLM, and also how are you going to configure this the RAG pipeline. Oh yes, of course. So for the presentation, I think let me just send the link in the chat immediately, because it is going to help you a lot in trying to go through this challenge. So let me get that real quick. So I've sent the link to the presentation in the chat. Actually, let me send a short link for easy tracking.
Yeah, we also have another question from Ezra in the chat when you get a chance, Fredy.
Oh, okay. Let me see. Okay, you explained a bit about how the chunking process affects retrieval, waiting mark, and what strategy would you recommend for optimizing chunk size overlap for academic space papers specifically. So the chunking process is going to affect because usually when you're trying to retrieve the chunks from your vector database, you are trying to get maybe a certain number of chunks. So let's say maybe I want to get maybe 5. And then the chunk size is actually going to kind of like help you configure how much context are you getting from there. Since if you say the maximum you're getting is maybe 5 chunks and then your chunk size is maybe just 200 tokens, that means maybe that could be pretty much maybe small. So every time you get those information, you're going to get less information. And considering the fact there is considering the fact that there is the overlap, that means you are getting pretty much less information because between chunk A and B, there is kind of like repetition in information, and that's done intentional. But yet again, if all of your chunks have a very small size, all of your chunks, if they are very small size, you're going to end up with pretty much less information sent to the context. And again, if you make the chunk size significantly big, that means you're going to be sending a lot more information to the LLM, and you might end up sending some irrelevant information, right? So because you're trying to force more context, that means it might even get some of the irrelevant information, right? So that's why you need to have kind of like a balance between the chunk size which you're going to keep. And yes, and the good thing in the notebooks is you can clearly see which kind of like which information those chunks have, and then that could easily help you be able to adjust that information. So remember, as I said, when you go to the it's in vector store anyways. So when you go to vector store, you're going to see this JSON here. It's going to have, basically, it's going to help you track maybe what you did and what were the results. For example, here we have this is the last run which we did. These are the configuration in terms of chunk size, the overlap, the configuration for retrieval, kind of like the similarity configuration, the temperature and the actual model, and then you can get to see what were the chunks, what information did those chunks have. And then from this, you can say, oh, looks like most of the chunks didn't have maybe relevant information, or it provided very few information and stuff like that. I think we could try to get an example. Let me see a good question. For example, this question is like, what deep learning models were used for banana disease detection? The answer is basically the study used SNet 152, exception rate 3, machine neural network, architectures, and everything. Then it provides the accuracy of each, and then it provides the source. Right, now we need to see what context was used for that. Now you first you're going to see the sources, or you're going to see, okay, that was the correct source, the correct paper which was used. And then you're going to see the retrieved chunks now. In these chunks, what did each of the chunk have? You can see the first one, it had the information from an abstract. And usually in the abstract of the paper, you could find the actual, maybe the final model which was used, or the final approach which was used. And then this could basically mean, okay, this was a pretty much relevant chunk. And then you can then explore other chunks which are also provided, and you can easily see if you are providing the most important information or not. As you can see, we got the abstract. I think we got this information probably somewhere in the middle of the paper. And then we got this one in the conclusion. So maybe looks like, of course, maybe in the conclusion, it was one of the areas which we were able to get that information. And also maybe you could look at some of the other things, such as maybe the time which was taken for retrieval. You could see if maybe a certain configuration took longer and stuff like that. But we're not going to care much about the retrieval time unless it's a very weird number, like several minutes or whatsoever. But yeah. So that's basically it on the introduction of the Twiga IndabaX challenge. And just to go back to Twiga, the reason for this challenge is basically to show that if you're trying to parse certain information from educational, let's say, context, you might try these approaches, right? And then, of course, maybe we try to make it a bit easy so that, for example, for the parsing, we already say the strategy to use is using llama parse, but then there are other strategies, and we have also explored with other strategies, but then the latest one which we're using is llama parse because we've seen how accurate it is. So again, you also try to learn how Twiga made these kind of like decisions in terms of how it worked. Maybe a quick hack, if you can be able to somehow see exactly in the Twiga warehouse repo how things were done, maybe that could help. And that might be true or maybe misleading, because in Twiga we're actually using the textbooks, secondary school textbooks at the moment, and then here we're using papers. So maybe you could try to get some knowledge on why exactly we made several decisions there, and maybe try to use that information in updating your strategy here, right? Updating your notebook here. So yeah, so are there any other questions? And yet again, I think we still have some time. And I think the challenge goes up to Saturday, right, Ronnie?
Yeah, Saturday morning is when the each group will present their solutions.
Yeah, so change goes to Saturday morning. So you guys, maybe for today, you can just take a look, just make sure you've been able to run the project from start to end and see what kind of results you get first. Because as I said, you should be able to run it from start to end immediately. And then you can start doing several adjustments, have some discussions, probably do some research in terms of like what exactly several parameters mean and stuff like that, and see how you can go further ahead.
And Fredy, you'll be back tomorrow with to answer any questions, right? For some support.
Yes. Also, I'll be back tomorrow to answer some of the questions and possibly support someone if you are stuck at a certain area. That's what we can do this in a rush, but at least we have seen how it basically runs and how to quickly set it up. So I'm expecting we're going to see some people have been able to run it.
Yeah. And to answer Juma's question, I would think the README is the guidance, right? Would you say, Fredy?
Yes, yes. So we have the general README, and also we have the README in each challenge. So you should get some pretty good information there. And yes, let me check the chat.
Yeah, Dr. Mollel is giving us pointers as well.
Okay, I see someone saying we have a number of visual workflows which can easily help us implement RAG. Of course, these workflows or these maybe some of these products which can help you, such as the N8N or something. So they can help, but again, they're somehow made for everyone. So sometimes they might not be good on the specific task you have. Since, for example, in our case, when we were in Twiga, we're trying to pass this like secondary and primary school textbooks. There are a few things which we had to do which are a bit specific, and you might be able or might not be able to do them in these visual builders, right? So when you go to something which is more production ready, you're mostly going to need to just really build something which is maybe from scratch or utilizing things which don't give a lot of abstraction, right? Like maybe a lang chain. So it doesn't limit you that much, but you can still be able to make a few specific things, right? And yet again, if you're starting you can try like a visual workflow. And actually that's pretty interesting. Maybe next time we could have some kind of like a RAG challenge whereby you just use some kind of like a visual workflow kind of thing to be able to build that pipeline. So that's also an option.
Nice. Okay, Fredy, thanks a lot. We should probably get going with PAWA, with Innocence before it gets too late in the afternoon. Any last comments, or should we let you go until tomorrow?
Okay. Just going through it. Yes, Mr. Michael, yes, we could use some evaluation frameworks, and I think maybe that could be maybe the way in evaluating specifically the parsing results on the parsing challenge. So I will investigate and try to use one of them when we're actually trying to do the judging on Saturday, and I will update in terms of maybe guideline into making the outputs fit the evaluation frameworks. And I think that's it on my side. I think I would welcome PAWA and also to answer for them to answer the question of the difference between PAWA and Twiga.
Okay, thanks, Fredy. Thanks a lot. Very thorough walkthrough, and definitely everyone read the README because that will help a lot. Innocence, are you still there? Welcome to start your presentation about your challenge for PAWA AI. Caribou-san.
Hello.
Innocent. Yep,
Hello.
Caribou. Nice to see
Am I
you again.
audible? Hello.
Yes, hi. We can hear you.
Am I audible? I don't
Yeah,
hear
exactly.
anything. Oh, okay. So, yeah, thanks so much for having me here. Yeah, so my name is Innocent Charles. I'm actually from Certify, and as some of you already know about Certify and also PAWA, so we are basically building products and different solutions and platforms, AI platform for people to use it and actually to embed into their software, then from one place to another. It can actually help them be having these exponential business goals and actually the new innovation. Yeah, so specifically, do you guys see my screen?
Yes, we can, Innocent.
Yeah, so
Yeah, you see my screen, right?
Yes, go ahead.
Yeah, so I think yesterday, if not yesterday, Mr. Mollel said a lot of things about PAWA. And basically there are two sides. So it's basically like the general platforms. So there is this side of chat whereby people can actually chat and actually get some assistance every day. And also there is this platform, this other part of PAWA whereby people can actually build stuff. So what you are trying to do is that the AI is becoming more advanced, but most important is becoming more costly. So as some of you now you're using some of the tools like OpenAI, Anthropic, and those kind of providers, but in reality they are basically charging a lot of money, and for I think I'm actually one of the victims. So at one point or another, it's very difficult to run into productions, and it's scalable. So we thought maybe that could be an opportunity for helping African peoples and also Tanzania to be able to have this advanced kind of platform whereby they actually build these cool stuffs, but actually minimize the cost of learning it. So right now, as Mr. Mollel said yesterday, we do have APIs. We do have APIs, so you're working on the platform whereby it will be no code, and like you guys are going to configure everything without doing any coding. So we're going to give those tags and actually everything. So yeah, so these are the APIs. We have chat request, whereby you actually chat, you actually send the request, and also like the model, what kind of models we are. So we have two models right now. We have this one, Ember, which is like smaller. This actually is the production one, so it's very small, very fast, but for some reason it doesn't handle so much kind of task, and also it doesn't have the tools and actually reasoning in place. Yeah, so we do have another model called Blaze, which basically do a lot of things. So it actually accepts the tools. You can configure your own tools. You can actually use the built-in tool. For example, we have the built-in tool for PesaPay that transfers money from one mobile wallet to another, and also there is this built-in tool for searching. It basically search and yeah, stuff like that. Yeah, so this is the endpoint for sending the request, and we do have these are the kind of parameters. So we're gonna choose the model and like what model we're using. So we have Power Ember, which is the simplest one, the smallest one, and also we have this kind of very intelligent kind of model, very sophisticated one. It's called Blaze. Yeah, so you can configure your own maybe roles, users, what do you want, maybe the role systems, like what other providers are doing, and also be able to have something working. Yeah, but also apart from chatting, also you can actually, so in lag, as Mr. Fredy said about in lag, what is the purpose of lag basically? So lag in the LLM we used to we used to send information to the LLM. Doesn't matter what that LLM, right? So, but the problem is due to the costful and everything around it. The lag came. Of course, the lag was there just before LLM, but it has become one of the most useful methods in LLM just because of being able to retrieve the most relevant context and actually send it to LLM. So, but how do you do the lag with PAWA? So we have this kind of different methods. So we have this endpoint whereby you don't need. There are two ways you can actually implement your own kind of custom lag from extraction, and also you do some chunking. There are different libraries for do some chunking, and also do embedding, and also do this kind of constant similarities from a vector database. And if you have the top K, then you do this system prompting and actually send back to the send back to the PAWA, so the PAWA will be able to understand what you want. You can actually do that. That's totally possible. But we thought because of we envision this future whereby these things doesn't have to be difficult. So we have this endpoint called knowledge base, whereby you basically upload the file, your files. So you upload your files and also the description of knowledge base. And then when you send the request, when you send a request to the model, when you send the chat request, just basically configuring basically just configuring the yeah. So when you send the request to a model, just basically configuring the knowledge base reference ID, as you can see here. So just send like how you send it, like the normal postman, but configure the knowledge base reference ID. So the importance of this is that you don't need to worry about the chunking, this quality, about extraction and everything. So technicality, we handle all of that, and you basically send it. So, and we have implemented this kind of technology called agentic, as we all know. There is this thing, agentic kind of things whereby the models have this ability of reasoning and actually know exactly what to use so as to answer the questions. So this power base, the model power base, can actually accept the tool. So you can actually configure different tools here. Function definitions, you can send function definitions. You can even send the custom built-in tool, which is website. So we have we have the custom tool for doing website. So if you want that, you can actually send it, and then the model will know itself whether does it want to Google or does it want to just use its own memory inside. Then there is this kind of reasoning, so you can configure different kind of reasoning, like reasoning, or there is also capability of thinking deeper. Do you want your model to spend much time thinking? You can also decide that. Yeah, so I said about knowledge base. So this knowledge base, the importance of this, I said, is that you don't need to worry about technicality to those methods like chunking, instructions, and also retrieval, embeddings, kind of things. So we just built, it's no code. You just upload the documents, and then we give you the KB reference ID, and then for every request we just send it. So we have implemented this option called is must. So is must, what does it mean? It means so if we say is must, it means for every request we are going to build embedding and also find the similarity. And we have the system prompt which makes PAWA understand and be able to answer the question based on that. But if if we remove this and say it is not must, and actually send the knowledge base ID without the is must, then what's going to happen? We have implemented the tool called lag. It's a built-in tool whereby instead of it, basically the model doesn't. We are not going to build the embedding at every request. So that actually helps you reducing the cost. And the model itself is very intelligent and very able to know whether should it use the lag, that tool, or should not use. So if for some point maybe it needs to use the tool, then it will actually go there and try to do the lag and the embedding and get information, and then also answer that questions. But if it doesn't need to use the lag, then there's no need of using it. So as you all know that the most traditional lag is that for every request, like Mambo, what is what that, then you guys you have to build the embedding and also use that embeddings and those, comparing the database you have and actually have the top K. So, but for now, for has PAWA, we have this tool whereby you don't need to do that. So it automatically the model will be able automatically to know whether does it need to use it or not. Yeah, and also there is inbuilt memory. We implemented the inbuilt memory, so it just sends the previous data, and then from that the model will be able to remember. The previous question, the previous question, the previous question, the previous answer, and be able to track the whole conversation. So this is very important, especially if you want to build production grade, chatbots and those kind of things. Yeah. So apart from chat, we also have I said about the knowledge base, whereby you just create the knowledge base and then we give you the knowledge base reference ID. There is also text to speech. The video, the voice, whereby let me just this
Yeah, sorry, Innocent. There's a comment in the chat saying the audio is not so clear. Could you maybe take a look at your mic setup?
Hello?
Yeah, there's a few comments in yeah, it's a bit muffled. They're saying it's not so clear.
Maybe
check your microphone setup.
Am I audible? You guys hear me?
There's a bit of an echo.
Hello? Hello? You hear me now?
Yeah.
Hello?
Yeah, now it's clear. Now it's clear, Innocent.
Okay.
Yeah.
Perfect. Yeah, so I was actually talking about different endpoints we have and how you guys are going to use it and actually build those stuffs. So I was saying about the chat reference, the create chat, chat request and different parameters you can actually configure so as to make it up and running. So I said about models, what models we have. I said about, the message, how to put the messages, and actually this is the overall request body. So this is live. You can actually, I don't know, let me just type it here. I think, we are good. So the good thing about us is that we have every advanced features you can think about. So there is kind of reasoning, there is kind of, tool calling and, stuff like that. So you can actually configure your own tool, your own function, and actually the model will be able to understand you. So you also have the built-in tool, this like website. I was thinking about that. This is how you can send it. And also the knowledge base ID. What does this mean is that instead of having your customized retrieval in a place, like you have wanted the custom extraction, chunking, embedding, and actually these similarities, you can actually skip all of that and just upload your images, you upload your audios, you upload your documents, and we'll be able to create the vector database for you. And we give you the KB reference ID, whereby for every request you send, you actually attach it. So if you attach it and say is must, that means we are going to run the embedding at every request. But if you don't specify whether should it be a must, then we are going to use the agentic kind of things you need. So we're not going to run the embeddings at every request. So that actually reduces you some sort of costful. So we don't need to charge a lot. Yeah, and also there is inbuilt memory, so we don't need to handle everything. Basically, just sent what was the previous conversations between PAWA and the users, and the model will be able to understand it. Yeah, so apart from that, we also have the endpoints for text. Yeah, text to speech. Text to speech is basically converting the text and actually to audio. So I think this is there in the production wise, and I think some of you have already play with it. So now you can actually build with it. So how are you going to build with it? So these are the parameters you can actually send. So this is the endpoint. PAWA API, person voice ERPO, and also you specify the PAWA API key. And the text you want, the voice. So for the voice, we have the AME, we have Riola, and also so for the models, this is the name of the model that you have to send, PAWA TTSC. And actually you're going to get that one. So apart from that, also there is the speech to text, whereby now we converting the speech, then you actually put it into text. So what you send, so these are the different endpoints, like API reference. So what is it? I think this one, text to speech. So send the endpoint, the API key, your file, whether it is MP3, WAV, or a video, whatever. the model. So configure the model and also the prompts. How do you want the, that transcription to be, the language, and also the temperature. So yeah, we also have the embedding database. The embedding endpoint. So if you don't want to actually use the knowledge lag, you can actually build everything from scratch. So it actually, chunking is very easy, extraction is very easy, but I think for embedding, you just need the model, the very accurate one. So we also have vector embeddings, whereby it's endpoint for you to build the embeddings. So you just upload your chunks and also give you the output of how those chunks are vectorally presented in a space. Yeah, so actually this is a model for embedding. We have this PAWA embedding, and also there is the kind of language. So you can actually specify the language you want, whether it is English or Swahili, but if you don't specify, it will be the MAT. And also this is sentence, this is our sentence. So think of you have chunks, maybe like blah, 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 blah. This is what chunks is. Then you send like this, then we give you the what. So let me just yeah. So do you see my screen right now? Hello?
We do see it.
Yeah, you see my screen. Yeah. So this example of this is APIs, and also this is what I was saying there. The chat request and how it look like. As you can see, like you pass the models, so you have these power embers. You pass the systems, they are texty, your role, and also the questions, your role users, and this configuration. So for example, when you hit it, so you can even supply whether you want streaming or not. So for example, this is how the request, the response will be. The current president is Madam Samia Suluhu Hassan. And also, for example, let me say streaming. So we'll actually go to the codes, and I think we have the blueprints. For now, we envision to be the no code. So we are actually working on the platform whereby it will be no code. But for now, for this Indaba things, we have the blueprints. So we have the blueprints codes whereby you guys are going to take it and actually modify the UI and also the backend for CPI and yeah. But all of things we're going to utilize the PAWA infrastructure for everything. So it's free. You don't need to have the API key from another providers or configure another provider models. Yeah. So for example, the tokens stream. Yeah, I think that was problem. This was supposed to be true. Yeah. So this is how the chunks returns. When you say streaming, it basically return the one. One chunks of another. And actually, if you're in production, I think this is very important. You don't need your user to stay. Yeah, so you can actually configure different model. For example, let me take this request here. I think this is very important. Let me just copy it here. So it's very important to understand how stuff are working. Configuration is very good also, but I think if you understand how everything is being built, you can actually that's what the differentiator is. So for example, here this is another request I've changed the name of the model. So the first one was Ember, and the second was this one is Braze. As you can see here, this is a system prompt. You can actually for example, maybe you can actually ask who are you? Yeah, so you can actually ask who are you to test it if it's actually working. Yeah, so just leave it. This is the yeah, this was one of the API, I think. Yeah, let me just so this is the PAWA Ember, and this is PAWA Braze. The first one was PAWA Ember. Let's see what does it say. So okay, Abali, I am a PAWA digital systems made by Zindi-Sartify. I'm built a lot in Africa. So that's kind of things. But how do you build it? For example, when you give it the purpose. Maybe your name is Loni. Yeah, your name is Lon. You are I mean you help people answer questions. You help people with different questions. Yeah, so for example, when I ask you who are you, it will actually be able to, so you can actually build the customized, very personalized chatbot. So you don't need to all about any power. You can actually remove those tokens by, my name is Loni, I'm a digital citizens created in Africa. So blah, 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 blah. You can actually see how it's going. So it will be yours. Yeah, and I think, yeah, so what else would you want to try? Maybe yeah, let's see. Okay, let's see about the functionality of the tool. So for example, here I have this tool. So this is custom tool. Maybe I have this, maybe I just want a model to be able to convert the Tanzania shillings into, the USD to Tanzania shillings. So actually you can't do that. No model can actually convert Tanzania shilling to, USD to Tanzania shillings. So there are tools inside of it. There are something called tool, whereby this model use it to retrieve, to connect to the, extra knowledge so as to get those outputs. But internally, that actually can't be done because things are changing. The rates are changing, so it can't be accurate. So we have this mechanism in LLM, this mechanism of tool whereby the model will be able to connect. So even our power actually accept that. You can send different tool. For example, here, yeah. So this year I'm having like for example. So when you send, for example, I just sent the request who are you, and it was able to answer me. And for some reason, maybe convert the ERPST to Tanzania shillings. Then yeah, so it's basically processing, and so can actually change it if you don't want, if you see like it's not actual speed. So I'm a power made in sensors per certify. Yeah, I don't know. I'd still not be able to understand it. Yeah, let's try. I think does not it doesn't decide to use the tool. Yeah, this was system. Okay, this was the system. Your name is USD, maybe USD to TZ converter. Yeah, actually, I didn't put I just put the questions to the system role instead of the user role. That's why it wasn't able to understand. Convert the 50 USD to Tanzania shillings. So let's see what's will happen. So as you can see here, it's actually called the tool call. So this is a capability inside the models. The model actually understands intelligently without any kind of supervision, like what do I need to use so as to solve these questions. So from the query, it understands that it has capability of converting, and there's this kind of tool. Then it has returned the tool. As you can see here, it has returned the convert USD and the arguments amount USD 50. Then from that, what does this mean? This means that for developer, you can actually pass this function, because now you already have the functions and also the arguments. So you can actually pass these functions and actually call these functions with these arguments. And maybe somewhere in your code, you have written something like, if you get the amount USD, then maybe there's kind of mathematics, or maybe there's kind of, calling the, external API for doing this conversation rate. And if you get it, you return the answer back to the models. And also the model will be able to understand, okay, now it is the tool, the result from the tool. So it will actually incorporate that to the, next questions, and it would actually get the answer, from that. So that was all about tool. Yeah, and also, for example, if you can even try these memory things and stuff like that. Yeah, for case of yeah, so you have this text to speech, for example, for some reason, yeah, Yeah, so we have this. You can actually see it basically returning something. Let me try. Right now, I can actually try even to the. So the idea is basically to understand stuffs, but don't worry, there is code kind of things like no code. But I just can sense like people should be able to understand how things work. So we'll be able to build, I don't know, where am I going? Yeah. Some reason. I think this one. I think this one. Yeah, if I've any question, you can actually ask while I'm actually explaining. So you don't need, you can even interrupt me. So yeah. I don't know where did I put it, these commands. So you can actually preview it and yeah. Yeah. So you also have the speech to text. So speech to text, this is form data. So for some reason the Swag actually hasn't configured to upload the file, but you can actually upload it and start soaking. So it will actually give out the text. So upload the audio and give out the own text. And also we have the embedding. So for example, you pass your own sentence, blah, 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 blah. So you have a large of sentence. You can actually send this to this model. And this model will be able to return the different embeddings yeah. So apart from that also, there is this. Let me share it here. Yeah. For this competition, actually, it's free, and you're going to use my. I don't know. I'll actually share my. So we're going to use my key there. Yeah. So we also do have the repo. It's actually free for you guys to use it. Let me just share it also. Yeah, so it has when coming at the public. So you can actually have the backend code, like how this it's being developed. So you just clone it and actually create the visual environment, and then after creating this visual environment, we'll be able to put all this configuration. So don't worry about like whether it's just for testing. And yeah, so these are some of the configurations. You put the prompts, what's your name, of course your API key reference, the name of the model you want to use, and also for the case of the voice, you basically put these endpoints, and also the configuration for the voice, and also configuration for TTS. Yeah. So also there is the front end part. What about this? We actually made this for one of the agents, WCF. So you can actually check it and change it, configure it, change the colors, and even add your own functionality, your own tools, for example, the payments, or maybe, for example, maybe we need your model to be able to refer something, or maybe like there's this feature of handover. If you need your model to have, your system to have the handover, then human in a loop kind of things, and then you can actually implement that. It's basically you put the tool and that will be triggered when the model knows like, okay, this time I just want to call this tool, and actually this tool will be able to send requests, some signal to external systems to call up human to come into conversations, and we'll after having this human AI users kind of conversation in the price field. You can build those kind of things, and yeah, so this is the Next.js, the simple app. I think you guys know Next.js, so you can actually learn it and start it. And yeah, so if you get any challenges, you can actually even reach me or Mr. Mollel or anyone in the team, and yeah, we'll be able to help you. Thank you. Any question?
Wow, thanks a lot, Innocent. That was very thorough. And of course, for setting up the repo and providing us the keys, of course, too, because I don't think that's free for others. Any questions for Innocent? Innocent, you'll also be back tomorrow, right, to support any questions?
Yeah, I think tomorrow I will show the demo. So yeah, I think tomorrow I'll show more. We are just working on the we just actually 2 days we launched the strategy. Our staging pipeline. So there is a lot of features we launched into our staging pipelines because we are working little. Very hard that we wanted to launch fast the platforms to the production. So there was a lot of changes to our staging. So for some reason, couldn't be able to have the demo working today. So I think tomorrow we'll actually show you. Tomorrow morning we'll actually show you what's going on. Like you'll see how.
Better. Okay, got it. Thank you. Yeah. Yeah, and the key is in the chat here.
Yeah, the key is in chat here. So don't worry, just use it.
That's great.
You can even but I do believe that if you have the access to the APIs, like what's going on, what's coming, and the API key, you can actually build amazing stuff. So I think that's what differentiates. That's what the differentiator is. Instead of relying on the you just configure the visual kind of things, but for now, we are going also to launch that. But I do believe that for the most ambitious products are built from, you need to understand everything from the core, from the pipelines, what's going on, be able to configure, to change those system message, be able to put your own tools, kind of things. And yeah, so yeah.
Okay, great. And we will also announce that there will be prizes for the winners of these challenges. And you can do it individually or in groups of up to 4 people. So we'll talk about that more tomorrow morning. Yeah, but thank you very much for everyone, especially the PAWA team and the Twiga team for providing these challenges. Yeah, it's not a small thing. They worked hard on making this possible and setting up the environments, the keys, and some guidance. So yeah, we're very thankful for that, making that happen. Okay. I think that's it. It is 4:25. So this is the end of the program today.
Lonnie, can I add something?
Yes, of course, Dr. Mello.
Yeah. So first of all, thank you very much, my friend Innocent. We've been working so hard for this competition, and so as a developer, take this as inspiration, build something which Sartify can't imagine. Just come up with a very, very innovations, ideas, and applications, because we are building infrastructure, we are building everything. So every tool is there, like Innocent passed us to text to speech, speech to text, and text to text. Just creating amazing stuff. Like you can creating voice call, you can create voice assistants, you can create chatbot for healthcare application, agricultures. You can even use those to creating Twiga. Like you don't have to. It's up to you. But the point is, sky is not the limit. Just think beyond what you can think. Thank you.
Yes, yes. Thank you for those inspiring words. For sure, this is our chance to do something like that. One of you will be judging, right? Correct, on Saturday?
Yes.
Yeah, one of you will be judging the winners, choosing the winners.
Yeah, I think Michael Mollel. Yeah, Michael.
Okay. Okay. Yeah,
we can discuss Innocent because I'm travel, so and then we can decide. Yeah, thank you. It might be Innocent or me, but one of us, yeah, probably.
Yeah, sounds great. Sounds great. Okay. Well, the work is ours. Yeah. Thank you, everyone. Tomorrow morning, bright and early again. We start at 8:30. Carol, 8:30. Yeah. Yep. With a talk about AI compute from Dan Desjardins, right? PhD. Okay. Yeah. So bright and early, 8:30 tomorrow. We'll open a Zoom link again at around 8. Have a nice rest. These are long days, but very, very fruitful. I think the presentations were amazing today. They will be shared, of course. Yeah, and that's it. Yeah, and yeah, of course, if you want to work on the challenge when you come to the hub, of course, bring your PCs, your laptops. For those who are, at the watch parties. Okay, great. Have a nice evening. We will post this on YouTube as well, and we'll share the YouTube link with the hub leaders. Yes, Akram or Isuza, yes, we will do that. We'll share it with the hub leader group as soon as we can close this and put on YouTube. Great idea. Okay, finish recording.
Yeah.